Okay. Um, let's see. Ugh, my desk is cluttered today. I got papers. Too many sets of papers. I gotta do something about that. My keys for some reason. Ooh. This, on the other hand, I can put my headphones away. Oh, let's change title. Let's change the title. Ooh, is it? Let's just call it Pacific Time. I always get confused about whether we're in daylight or standard time. Which is it actually? There should be, is it daylight right now? No, right? Because no, it is. Yeah, we sprung forward. So we spent most of the year in daylight saving time. So is right now PDT? Yes, it's PDT. No. Yes? I'm still, it's PDT. It has to be. It's PDT right now. Okay, one thing that's freaky is here. Look at this. I'm like trying to figure out if it's PDT or not, and everything I search has like I don't know, like a prefetched time that has nothing to do with the current time of day. Let me do my transition so you can see. Every single thing I fetch, like here, it's like 155. No, this one has 602. I don't know how these scrapes worked. I guess it just scraped some text and the time was in the text. Oh, I wonder if I go to my favorite site, if it clarifies whether it's daylight or not. Not that it matters too much. Oh, Europe starts daylight saving at a different time than the US? I didn't know that. That's interesting. Anyway, okay, I updated the title. I think I'm live. Let's get like my correct tabs ready. Oh, this crashed. Okay, there we go. Let me close it. Okay, ooh, my PC's angry for some reason. Hang on, let me do some management here, unless I'm just gonna system crash, which is possible. Okay, yeah, I think my whole thing crashed. I wonder if you can hear me or if I'm about to freeze. Hello, hello? Sorry, my system's having an angry time right now. Um, Here, let me just, I need to check on some settings. Kill that. Kill Slack. Anything else I can kill? No, I need Chrome. I don't have Edge sitting here open somewhere, do I? Great, I'm glad you hear me. Sorry, I'm just muttering because my PC froze. But yeah, it unfroze. People can hear me. That's great. Hopefully it doesn't freeze again. I did have um a Slack instance and a Discord instance open that don't need to be, so I closed them. Hopefully that gives me enough RAM to do this. I think for the most part we're gonna pick up where we left off yesterday, and then welcome to the new weekly stream. I think this is the new time. Obviously I'm a little late today, so not like 9:20, but 9 a.m. Why was I late today? Bad planning, I guess. Since it was 9, I knew I didn't need to set an alarm, so I didn't. But that also meant that, like, normally the alarm tells me, wake up, get ready for stream. No alarm, I was already awake, and I messed up the whole, like, getting ready for stream time. So I started getting ready, like, 5 minutes before the stream was supposed to start, and that's obviously not enough time. So, lesson learned. Maybe I just need to set an alarm even though I know I'm already going to be awake. Just to be getting ready for the new time. Also, this paper, I don't think. Oh, no, no, no. It was up here. With that title, though, I remember Fast audio visual, I don't, or sorry, fast audio video, I don't remember speed by simplicity. This makes me want to look in my history real quick. Did we look at this paper already? Did we look at that yesterday? Speed by simplicity? We did. Oh, it was I complained about that one. That's right. I wonder how it got so many votes. Yeah, I don't know. Okay, we definitely looked at all of these top ones. Okay, I don't think I see any change here then. Oh, open pipeline for long horizon deep research trajectory synthesis. That's like, if this is just like an auto research sort of thing, deep research trajectory synthesis is an interesting title. I guess I want to look. Anyway, let's grab the papers that we opened last time real quick, and then this one that I just opened. That gives us like 4 to glance at real quick. We'll see if any of them are worth a closer look, and we will go from there. As always, feel free to ask any questions in the chat. I would love questions about the papers that I'm reading. Also clarification, like if you think I get some detail wrong, that would be pretty awesome too. Oh, I always move the mic, so I am going to do my own check real quick, real fast, just of how many decibels I'm hitting. That looks pretty good to me. I'll try to remember not to freak out and scream or anything, because that always messes with my audio. All right, so let's look at this. Let me check and make sure that the verticals are all looking good. Even on this paper? Oh, yeah. Cool. Okay, we're chilling. Awesome. Okay, let me bring the chat back, and we are ready to rock. Oh, hang on, I gotta... Okay, no, not important. Okay, cool. Just got a ping on my phone, but it doesn't matter. Silencing that. All right. Open Researcher, a fully open pipeline for long horizon deep research trajectory synthesis. So they train deep research agents, and that requires a lot of context, I think there's, or no, long horizon trajectory. So you have to have search, evidence aggregation, and multiple steps of reasoning. Okay, but existing data collection pipelines make that difficult to reproduce. So they have a reproducible pipeline that decouples one-time corporate bootstrapping into multi-turn trajectory synthesis. Using some GPT-OSS as the teacher, they synthesize many trajectories, including over 100 tool calls, which gives a big long horizon tail where some tools aren't called as much as others. Because the environment is offline full instrument, it also enables controlled analysis where they reveal practical insights in deep research pipeline design, including data filtering strategies, agent. Okay, I'm getting the impression that my initial like auto research thought is too recency pilled, and there is like some task. Like the deep research thing is probably some task in language that I'm just not so familiar with. I guess, okay, let's try to understand this real quick. I will start by looking at the things that they compare themselves to. And it looks like the main comparisons they have is they say there are some dedicated agents, sort of like theirs, but they also just compare themselves to foundation models using tools. What is the goal in this task? Okay, so their agent searches for things, opens relevant links, and then finds information. Is this like what's an example of like a query in the task? Because this is just showing us the browsing mechanism, right? We can search, we can open, we can find, but what sorts of questions are we getting that require this? Just challenging question answering, like challenging questions basically. And then they just create an offline corpus where they know they create an offline corpus, and then based on the corpus they take the teacher model to generate many trajectories, and I guess they guarantee that the questions can be answered in the corpus. Oh, here they describe the deep research workflow. Most deep research agents follow a React style paradigm. We formalize this interaction process as follows. Given a query Q, a system prompt S, and some tool metadata, the model interleaves reasoning and tool calls, receiving observations from the environment until termination, which forms a trajectory, which is a sequence of reasoning, action, observation triplets. Okay. Where they have the reasoning chain of thought, the action, and the observation respectively. Oh, so are they calling a tool every time no matter what? Or sometimes can the tool call be like null? Like, can it sometimes just do chain of thought in its text space, I wonder? At any step, the agent's policy generates a current thought, action, and action based on the history of previous interactions, and then based on those, obviously, you get the observation because the environment executes the action, returns the tool response, and updates the trajectory. Maybe that means you do always have to have a tool call. And this loop continues until the model stops issuing calls and decides something is the final answer. Cool. This looks like just a way to answer complicated questions then, not like what I originally had in my head. Granted, I guess you could say all research is answering, arbitrarily complicated questions, where instead of the tool call being the web, the tool call is being able to launch an experiment in your workflow. I guess in that sense, they're kind of the same, right? Hi, are you planning on the computer vision timeline/ring list video? If so, then is it going to be pre-recorded or stream? I am planning that. I think about it a lot. And here, I'm going to close this because I'm done with this paper. I am planning it. I think about it a lot. I started talking to some people about their opinions about some of those papers, and in my head, the way I would love to do that is I do a lot of the work in just like working streams, kind of like this, except obviously not the weekly, because the weekly is for reading like random papers, right? So in my perfect world, I stream a few hours a week aside from the scheduled stream, and in those streams, I'm just kind of getting all my papers lined up, and people that come to the stream are basically getting the behind the scenes and maybe even contributing their own thoughts and opinions on what should be in that. The actual recording for those, though, would I think be best. Like, if I streamed, it would be like you were literally watching me record. Like, I would not read chat unless I was taking a break from the recorded portion, right? It's like I would kind of turn off the YouTube voice or whatever, look at the chat, and then look back. But the thing is, for that series to be proper, it's like the style of this is like, oh, I'm reading a paper for the first time, right? With those, I don't want to be reading a paper for the first time, obviously. And I want to do more like, I don't think I'll do any fancy animations because that's just not what I like and not what I know how to do. But I would like to have some combination of like maybe it feels kind of personal when I'm drawing the diagram live, but also like a little bit of prepared stuff. Or even if I'm drawing it live, it's like it's already planned and I know the points I'm going to hit in the paper. It's like, okay, time to whip out the diagram. And I also want to have like, before I'm presenting the paper, some of these will require very quick like callbacks to other papers that won't deserve their own place maybe in like the series, but I need to know that before. It shouldn't just be off the cuff, right? So, sorry, I made this way too long, but I would love to plan on stream and then record off stream. Uh, the reason it's not already happening is just because I'm pretty busy. And like that last stream that I went live randomly, I think also on a Sunday, but not, this is meant to be the weekly, right? That Sunday was meant to be like a side thing. I was going to go through some vision papers like that, but people just asked so many questions that I didn't get through any papers. So I'll have to see. I think if another week passes and I don't make any progress on stream, it will be something that I just start kind of trying to get together offline. I think the hardest thing is picking the first paper, and actually this is something we can talk about. I kind of want to start with this paper. I'm thinking of starting with this one. Um, no, what is the name? I know who wrote it. Okay, I'll just go to his scholar, although this guy has so many papers, it's going to be tricky. This should be one of the more cited ones, though. Let's see. Really? No? It's not this one. It's older than that. It's not this one. It's older than that. It could be that. I don't know. I need to find... This is not quite the right paper to start because... Here, I have it now. This is not quite the right paper to start, I think. But it's something around here. Like, no, not Lynette. Lynette could be... See, that's the thing. Okay. So I'm not sure if I want to start with data or like... I don't think I would start with Lynette, because if I was going to go old, I would start with like Backprop or something even older than Lynette. Um, or I could try to go to that, what's the Schmidhuber paper before Lynette? I don't know. That's the big question, is how far back to start. Because the thing about starting with something like Lynette is I would do Lynette, right? And then eventually I would get to something like, I actually want to do this. Like one of these. This is not the right... Okay, actually, I'll just pull up this because I'm not going to just sit here searching for a long time. This paper, Deformable Part Models are Convolutional Neural Networks, is talking about something called deformable part model, obviously. It does not propose deformable part model, but I think I would like to do deformable part model. And it does feel a bit weird to start with some old CNN and then go to DPM. And then I wouldn't do this paper, by the way. Or maybe I would. Maybe I would do this paper. Maybe that's a good way to kind of bridge things together. I don't know. See, these are like the decisions I have to make. Um, how long should the series be? What gets included? What doesn't get included? And like, there's some things I would like to like. I would kind of like to do Hog. Um, I would kind of like to do this one probably. But like, then this is before any of my data papers, I think. Right? But then is this really the history of modern CV? I think it kind of is, because this is a lot of like what a lot of us had in mind when we started saying feature. You know, we had Hog, we had Sift, those were features, and I think when we moved towards CNNs, a lot of people that did really well with CNNs were people that already had this idea around feature. Um, where a feature is a descriptor, kind of like a histogram of oriented gradients. And a lot of people would think about the deep CNNs as kind of a proxy for that, and that's even the whole point of this paper that I foolishly closed. I think I just misspelled Gearshik. No, I got it. Okay. Like, that's kind of the point of this, actually, is that CNNs are DPMs are CNNs. Like, that's it's explaining how CNN is equivalent to a multi-component DPM. So you don't have to take my word for it that a lot of us saw, DPM and CNN and vice versa, or a lot of us saw Hog and CNN and vice versa. Like, there are papers from 12 years ago saying that. So, yeah, see, comparing the different levels of CNN features to the different levels of the Hog of a pyramid in the DPM using Hog features. Like, here it is. Here's the diagram making the argument I am. Hog feature, COM feature, right? Like, this isn't something I'm making up. So, yeah, I guess there's a sneak peek, right, into what I'm thinking about when it comes to that. And who knows, we might get through a couple more papers and I might start doing some of that planning today on the stream. Not start. I planned, but like, continue planning. All right. What will happen when a large portion of AI research is automated? I think I'd say what would happen if a big portion of AI research is automated. And I definitely don't know if we get there, because I guess it really depends on what portion is automated. Like, if it can automate literally everything that even the best researcher does, well, there's so much of it and it doesn't sleep that, I guess we cure every curable thing and we, I don't know, make rockets go really, really fast, and any other wild technological thing you could imagine would just be at our fingertips. And the main limit would be just what we can build physically to support the experiments that the basically godlike system is asking for, right? Um, I don't think that's very likely, but I don't know. I see auto research as being in its infancy, but already in its infancy, perhaps it can do some useful things, and I hope to see it do incrementally more useful things. I think I answered this in the stream last time, so I won't spend too much time on it, but a thing I would hope to see it be able to do in the next year or so is replace the part of every research project where it's like you have the good idea and you know that it's good without bells and whistles, but in order to compare to sodas, it needs bells and whistles. I would love to see auto research be able to figure out bells and whistles. Like, oh, if you had just turned the learning rate down, from 3 to 2, then suddenly your performance would have gone from 48.9 to 49.2, and suddenly that column, yours wouldn't be weaker than the old soda, right? Like, it would be nice to be able to automate some of that. On the other hand, I feel weird saying that because it's like we already know, those of us that think about these things already kind of know that that's dumb, right? So why are we wasting time on it in the first place? And does the auto research that knows how to do that just kind of launder the fact that, like, does it just make it even easier to continue to have that dumb expectation of each other? Uh, Kind of like how the fact that a tool right now, like if I want to look at some of my video data, I can make a Gradeo dashboard in 10 minutes, even though I don't know how to make a Gradeo dashboard. But that also means that, like, sometimes I'll ask a coworker, or they could ask me, hey, Matt, can you spin up, this interactive dashboard, these components in this period of time? Or I might ask one of them, like, hey, can we, like, here's this metric, can we, like, get that running, like, in a fully automatic, no one has to touch it pipeline, just listening to whatever? And, like, those went from being, okay, sure, let me learn that library, it'll take a few days or a week, to, we expect that of each other in less than an hour. So To what extent does something like that actually help? Automating the bells and whistles, to what extent does that help versus to what extent does that just create even more expectations that just waste even more time? I don't know. Some of that's useful work. And when your system really is the soda, obviously it's better for it to perform better. But in research, to some extent, the fact that we want to achieve sodas is just trying to perform that the method makes sense, right? Or at least that's how I see it. Like the main point is that the method is elegant and the method pushes knowledge forward. The fact that it's soda is just to prove that those things are true. So would it be nice to automate that part? Yeah, but maybe it would also be nice if we just fix our expectations a bit. And I don't know. But it's hard because in an empirical field, what do you do when someone doesn't beat sodas? How can you believe that that thing is good? I don't know. These are, I think, tricky questions. Anyway, let's get the timer and let's do another paper. Oh, I should take a deep breath first. LLM is token compressor and decompressor. Okay, so I'm curious how they're compressing and decompressing the tokens. They say they achieve 18 times token reduction. That makes me think we're not making tokens smaller, we're just pruning tokens. Semantically dense segments receive more Z tokens. What is a Z token? Fine-tunes a pre-trained LLM to translate long text into a compact internal language of discrete variable length latent codes. Term Z tokens. Okay, so the tokens can be variable length, and they're also internal tokens. So maybe we have a smaller vocabulary, which means the tokens could be smaller. Let's see. So the framework consists of 3 components: compressor, which is frozen, inference module, and a decompressor. It supports 2 usage paradigms. In the first, we directly feed the compressor representation to the decompressor to perform the downstream task. In the second, we run the inference module in the Z token space and then invoke the decompressor. Okay, so we have these tokens here, and we get out. It's sort of like we're merging words into tokens, and that gives us fewer tokens. So it's not pruning, but it's creating tokens that represent the information more densely. Does it work? Oh, this is where it's going to be tricky to see does it work, right? Because here, I don't know, we're not getting an equal token comparison, right? So it's how much of a hit in performance can we stomach? I want to see something where they maybe somehow convey the benefit and the speed up or something. Okay, this is comparisons on reconstruction task for different token compression methods. This makes it look like theirs is better, right? It's getting the better blue, which is comparing n-grams. Probably it's blue 4, right? Yeah, blue 4. So it's taking sequences of 4 consecutive words and checking how many times that overlaps, I suppose, for having compressed and decompressed the tokens in Wikipedia. Normally, these n-gram metrics are kind of weak. However, in this case, where it's a reconstruction task, I think that the n-grams are very appropriate. Because you want to get the whole document back, and sliding basically windows of 4 words over and seeing where they match is a great way to see if we're getting all the words back. On the only case where that's not true is what if I've reconstructed the whole effective meaning of the article and just changed the words? And obviously blue will miss that because it's looking for the exact word matches. And cross entropy, which I believe is basically like a 1 gram, that would be even weaker in that sense. That's not capturing meaning at all. Probably. So sorry. All I'm scrolling for before I close this paper is I want to see something like this table, but that tells me how much we're speeding up or reducing tokens compared to the default Chanwen. So, but that doesn't seem to be jumping out at me. Is it jumping out at any of you? Here, my clock is covering the chat. Uh, oh, 4 times compression. Perfect. Did it say here what it was? How many times? No? Okay, so we'll just focus on this table then. 4 times compression. And, oh, in some cases, it looks like they can even improve, right? This is a metric I think we're higher. Yeah, because these are QA data sets, so higher is better. Yeah, so they take a hit on these. They improve on these. By the way, red being best is certainly a choice I don't encourage. It's not standard at all. I think people expect to see red as problem, so maybe don't do this. Ooh, they report the speed ups here. Compression inference time and GPU memory with and without compression, 2.1x. In the case where the input is very large, which I think this is the more important case. I think the case with the smaller inputs matter less because with these systems, we're just trying to scale, scale, scale. So I'm fine just fixating on the 2x, I think. And that's pretty decent. Okay. Cool paper. And pretty straightforward, right? Let's just compress the tokens by how having a frozen LLM that can merge my tokens, and then I have new tokens for the merged internal vocabulary. That's pretty neat. All right, let's do another paper. Here, I'm going to take a bite of this donut first, though. Eating a donut with a fork to not get my peripherals dirty. I just got a ping from a friend on my phone. It would be kind of fun to do like one version of the computer vision history thing where it's like computer vision as it relates to modern CV, right? So I'd be missing a ton of stuff that's really important, but maybe just that is not super popular now or doesn't relate to things popular now. It would be fun to do a version of that that is only Schmidhuber papers, I think, where it's like, so I wouldn't do Linnet. I would do the Schmidhuber thing that predates Linnet. I wouldn't do AlexNet. I would do, what's it called? Domnet? What is his, let's see, Schmidhuber before AlexNet. What is that one? I should remember. I feel DanNet. That's what it is. DanNet. We got to do DanNet. And so instead of doing ImageNet, we'll look at like the big medical imaging challenges that DanNet competed on. Because I don't know if you know this, but do y'all know who Schmidhuber is? Jürgen Schmidhuber? I'll wait till someone says something in the chat. If not, this is something to explain because it's a bit of the whole like Schmidhuber versus LeCun beef is a bit of a meme among me and my friends. And I would like to reference it on stream, but in order to do that, like people need to be in the know. So let me know if y'all know who Schmidhuber is. And while I'm waiting to see if anyone says anything, I will do another paper. Okay. Fast decoding for diffusion LLMs via training-free self-speculation. I said I think I could do this one because I know diffusion, so like diffusion LLM, that shouldn't be too hard, right? Standard block diffusion decoding accepts drafted tokens by confidence thresholding. Oh, geez. Confidence thresholding. Do I think I'm familiar with that accepting draft tokens concept? I guess I don't know enough about diffusion LLMs. They insert a self-speculative verification step. The same model under block size 1 autoaggressive masking verifies the first contiguous masked span, accepts tokens by rejecting sampling, and falls back to standard diffusion decoding when verification is not invoked or terminates early. Verification mode attention masks for right shift and standard position aligned diffusion LLMs. We draw the full block mask for illustration. This will take me more time than a minute because I'm not so familiar with this confidence thresholding step. What I think it is it's a way to potentially greedily decode some of my tokens and not finish all of my diffusion denoising steps. Whereas if we fail verification, we would just continue denoising. And it looks like what they're adding mainly is a self-speculative verification step. Where maybe if we look at the diagram, I will understand. So here, let's full screen. So sorry, shorts peeps. Let's full screen this though. I don't even think I'm streaming vertical today, so who even cares? Well, except sometimes I like to take these for shorts later, but let's see. We got the sequence. We have stuff, I assume. Oh, cache blocks. Okay. And then masked in the current block and then unmasked in the current block. Why is this already unmasked why is this unmasked in the current block? Are we not going from left to right? Why is that confusing me too? Or is that something that we already decoded? And so we're masking these, we're still trying to decode these, and we already know this one, and we're just trying to fill in the blank. Is that... See, this is where things that I don't know about diffusion LLMs. So, like, I know diffusion for images, obviously, or videos, but, like, yeah, the fact that I have cache blocks and then unmasked and current block is kind of throwing me off a little bit. Okay, so we can invoke, okay, so we have the standard block diffusion decoding where we do a draft forward and we have some kind of confidence thresholding, and if all the things are accepted over the threshold, then we decode. At any point that we're in the standard block diffusion decoding, we can invoke what they propose, which is a training-free self-speculative decoding. And in that self-speculative decoding, it looks like we attempt the draft forward, but instead of immediately just taking them, and we have the probabilities, but instead of thresholding on those probabilities, everything so far is the same. We have the sequence, we have the draft forward, we get possible tokens, and we get probabilities. But instead of thresholding, we are going to do this step here. Oh, this comes from, okay, so let's ignore this middle part because actually first we do a verification forward step where we take what the sequence would be if we accept these tokens and we do a verifier forward, and I think we compute the probabilities only on the portion that we decided to decode, and we compare these, and if this token seems very improbable in the final sequence, then we say that it's to be rejected, right? It's just P over Q. So if Q over P is really, really small, we reject. Whereas if Q and P are pretty similar, we can continue. Is that what it's saying basically? And in the reject case, we resample from the residual. Wait, but then what? Okay, so we can take Q minus P, and we can resample. Resample what? How exactly? Like just take the next CC, like where does G come from? That's not like the next most probable token, because we're taking Q minus P. I don't quite understand. Arena, you know Schmidhuber? That's great. Am I saying your name right, by the way? Feel free, if I ever mispronounce a name, or like even if it's a username, like feel free to just give me a little like phonetic guide in the chat, and I won't say it wrong again. I try to say names correctly. Verification mode attention masks for right shift and snare position aligned diffusion LLMs. We draw the full block mask for illustration, then practice only C sub T is verified. Oh. Okay. Lightweight routing policy decides when. Oh, okay. So D is a routing policy that decides when it's worth invoking the verifier, which I suppose would make sense primarily when we have many tokens with a high probability of being accepted mixed with some tokens that have a decent probability of being rejected. Because otherwise we should just stick around in this regime and keep going until we get good tokens out. I want to understand the resampling a little bit better, or do I? Or is this good enough for me? Kind of want to know what the verifier forward and the router are. I think those are the main things I actually like to know. Okay, they describe the routing policy here. So minimum span policy, first contiguous mask span C sub T. If the size of it is greater than some threshold, so it has to be big enough. So like I said, we have to have a big enough set of tokens we're trying to demask. Demask? We're trying to denoise, or like big enough set of tokens we're trying to decode. Predict. We have to have, then we have a score threshold policy, so the expected number of accepted tokens is high enough. Yeah, we have to expect to accept a lot of tokens. And then a hysteresis policy, which says, what? Okay, I'm not understanding this part. Where the score is greater than or equal to some on threshold on, and then as soon as it's less than off, off. What? Oh, they're just explaining the resampling, right? Is that what this is saying, or is this explaining the whole block? Verification mode attention mask for right shift and snare. No, that's explaining I think the whole thing, not specifically how they handle G. Do I want to try to find this one piece of information, which is what is hysteresis? Yeah, sure, why not? What is the hysteresis policy? The hysteresis state, H equals on, set H to off. Okay, so if H is on and the score is under the threshold that says we turn off, set H to off. If H is off and it's greater than or equal to the threshold that's on, set H to on. Verification is invoked if and only if H is on. So the motivation is to avoid oscillation between speculative and diffusion modes. Interesting. The only reason I'm a little confused is because I believe we're using the same scores here. And so I suppose it's saying that there's some threshold that's lower than tau score, which, if we're over that threshold, we're just in hysteresis mode. Although, I still don't understand, because then as soon as it goes over the score, it would be over the threshold, and we would be in on state. Although maybe what happens is, the first time it spikes is not the time that I update S, so it's like it spikes, but we're off, so we're off, and then we go and we turn it on. So like if it's on twice in a row, then we'll go into the mode, maybe? That's, I think, the way I understand the most easily, especially because they say they want to avoid oscillation. So is it just saying we need to be like on 2 in a row? Because let's look, T on is 1, T off is -5. Um, and what's the other tau? Like what's tau, like the main score threshold? 0. Oh, so it's the opposite of what I assumed. We have to get over the threshold at some point to invoke the, this makes more sense than what I naively assumed. We have to get over this high threshold to turn it on, but then we don't turn it off unless it gets pretty low. And in the meantime, we use it anytime the score is over 0. That makes sense. Okay. Arena. Great. I'm glad that I'm saying it correctly. Resampling the first wrong token, probably. Yeah, Arena, that's my guess as to basically what they're saying. But resample from the residual, I think that's the main part that's getting me, is just like, is it just the, at first rejection, we resample from the residual distribution and end the speculative segment. Like, that's the one. This is something I think if I knew language better, I would just know what this meant, but I don't. So that's the part that I'm missing, is what is the residual resampling specifically. It looks like there's a lot of papers that I could get that from if I really wanted to, and I'm trying to decide if I really want to. I kind of want to know. I'll probably run into this again if I ever read Diffusion LLM again, so maybe I should just see if I can find one of the first papers that they say explains that. It might be that paper that we just went past, but we can also move up higher. Yeah, let's see. No? Okay, I think we will go to that EDLM paper then. Energy-based diffusion language models for text generation, and this looks like it would have been one of the earlier diffusion LLM papers, so probably a pretty decent one. Oh, it's not as cited as I would have expected, but maybe this whole diffusion LLM space isn't as cited as I would think. Let's see, are they going to say that they... Okay. Our analysis reveals that this degradation is a consequence of an imperfect approximation used by diffusion models, energy-based diffusion language model, an energy-based model operating at the full sequence level for each diffusion step. More specifically, we introduce an EBM in a residual form and show that its parameters can be obtained by leveraging a pre-trained autoregressive model or fine-tuning a bidirectional transformer. We also propose an efficient generative algorithm via parallel importance sampling. Okay, are they going to talk about this residual resampling idea, though? Hopefully. I don't think that's what this is. Whoa. Why am I not? Oh, I'm pressing enter on that, okay. For example, an original discrete diffusion model learns to predict independent distributions for each token in our framework given diffuse data at time step t. We introduce, no, I don't think. Or is this in the following text we use, like what I'm looking for basically is, I didn't close the paper, did I? What I'm looking for is, oh, are they explaining it here in their own paper and I should just read better? Connection to AR guided residual energy correction. Both of them exploit AR versus diffusion discrepancy, but differently. EDLM uses a global multi-sample reweighting, while S2D2, which is this paper, by the way, applies online local correction through speculative acceptance and residual resampling. Oh, I think the residual resampling is new then. Let P sub I be the draft probability of sample token X hat sub I and Q sub I. And Q sub I is the verifier probability under block size 1 AR mode. The local residual energy and acceptance form R, negative log of the verifier probability plus the log of the draft probability, and the minimum of 1 and the draft probability, sorry, the verified probability of the draft probability is equal to the minimum of 1 and e to the negative expectation of x hat sub I, where x hat sub I is the resampled, is the sampled token. So the lower residual energy drafted tokens are more, no, this is just describing the acceptance criteria we looked at above, where the lower residual energy drafted tokens are more likely to be accepted, while higher energy mismatches are corrected via residual resampling. But it still doesn't quite explain, for me at least, who doesn't know what is the residual resampling. Decoding returns to diffusion with residual resampling. Residual resampling. Maybe the word to look for is resample. Okay. We can conduct efficient parallel sampling by 1. Sampling multiple x sub 0 predictions from the diffusion denoiser. 2. Feeding samples into energy function parallel to compute energies. And 3. Resampling a single x from the pool according to the energy values. Oh. So is this saying... I'm still not quite, like, this is saying we would resample some x according to the verifier probability minus the draft probability. Oh, is this saying we would take all the verifier probabilities for the token in that position and subtract them from all, like, not just from the token, but from the entire pool? And so is it basically like we would sample the token where there's the biggest difference between what the verifier suggests or thinks and what the draft would propose? Like basically whatever the draft thought would to be least likely and the verifier thought to be most likely, that would be what we resample? Is that a good way to understand it? Maybe. I think I've spent enough time trying to understand it on stream. If this is something I really care about, I should spend my time muttering incoherently off stream. So let's go to another paper. Okay. Okay. So scientific multimodal foundation model at trillion scale, and they do say 1 trillion parameter level. So this is Intern S1 Pro. Let's try to see if we can get anything about the design. I do expect this to be in general lighter on some of those details. So there's an expert expansion process where a group routing strategy ensures well-trained top 1, top 2 experts are distributed across groups by having some router which can route to multiple different experts, which I guess just allows us to scale a little bit better. Yeah, I suppose it's just a better process. Did they not have a router before? Okay, that's a little weird to me. What was this saying that they didn't have in the S1? I guess they used to have expert expansion, whereas now they have the routing. Or maybe before they would route to specific experts, whereas now they're densely routing, like, sometimes you do the embedding, but not the FFN. Maybe that's what it's trying to say. Training with the group router can achieve load balancing. Yeah, I get that. Looking at the amount of time on the clock, it's like I was hardly even trying to do, like I was hardly even trying to do this properly, right? Let's try to figure out what they do though, compared to their prior stuff. So I'll look at this a little closer, right? Figure 2. Let's find in the text. Okay, so Intern S1 Pro is derived from Intern S1 through expert expansion. And this expansion process, we incorporate the grouped routing design where experts are distributed into groups. Okay, so we ensure that experts activated within each group correspond to the top 1 or top 2 experts prior to expansion. While this approach results in some homogenization of expert activation during initialization, the experts naturally differentiate after a few step training. Okay. Hold on, give me 1 second. Okay, Sorry about that. My toddler stubbed her toe, so I was checking on her real quick. She's getting a Band-Aid right now. Okay, so this router, I suppose what I didn't understand before is this was not comparing it to anything before. It's saying that they take the experts from the S1 and they basically copy them for the S1 Pro, right? And this is a way to immediately get a lot more parameters. And we also know we have this stable initialization because we take these existing experts, right? And they say that even though this means originally the initializations are homogeneous, which means the fear is that as we continue to train, the weights will kind of stay close because we started them close. What they say actually ends up happening because of the way that the router is going to work is we are going to quickly have those kind of move apart and separate and, actually behave like separate experts. And the group router can achieve absolute load balancing across devices for MOE models with the top K configuration of K equals 8. And so I think they're just showing how they get the same kind of distribution, right? They can still get just 4 different experts activated. And they can even balance it more smoothly because like maybe before if you did a top K, your experts that actually activate would kind of cluster on a single device, and that's not ideal if you want to achieve like consistent throughput because this device is going to be very bottlenecked. But they can spread them out pretty nicely, which is important when you're scaling to trillion parameters, right? Those tricks really matter because otherwise you can't fit things on the card, or you'll just be sitting there for 4 times as long because 4 of your experts happen to be running on one card. Granted, that kind of gets spread out across layers, but then what ends up happening is you bottleneck the ability of the layers to proceed because everything is stuck waiting for the one layer. So that can even spiral and be maybe even worse than I said in the worst case. Let's see. Okay, so do we have any other things that they're claiming are new or novel or interesting? Oh, I guess this Fourier-based position encoding, right? So large models have achieved remarkable success processing information through discrete tokens, subwords, image patches, audio frames, whatever, but the physical world operates under different principles. Light has wave-particle duality. Sound has continuous waveform. EM signals possess spectral characteristics. So using just rope, they say. They're just saying traditional methods such as rope inject sequential order, but they're weak in explicitly modeling continuous wave-like nature in physical signals, which is true. So what are they going to do instead? Yeah, because it creates a gap because it flattens them into token sequences. And so even in images, we already struggle with this, right? Images are 2D, but we flatten them into 1D. Rope kind of helps this because we can put these tags on each part of the patch that says, well, this patch was here, this patch was here, this patch was there. But with waves, that starts to become really hard. And if you remember from when we did audio papers a couple weeks back, a lot of what happens in any given audio paper is just somehow trying to figure out what positions to give the audio, mainly to line it up with what's in the video, typically, right? Like we have these video positions and these audio positions, and since the audio happens at the same time as the video, they need to line up. But the issue is, like, once we discretize those signals, because we have to discretize them somehow to process them with the model, obviously things don't line up naturally. We're not just going to happen to get the same number of video patch tokens as we get audio tokens, right? So we have to do other things to like stretch them, line them up, and then give them positions that make sense so that they can work together. But apparently this is going to do something a little different altogether, right? The other things we've looked at are kind of like hacks on top of rope. This is making me hope it's not just like a hack on top of rope, right? Fourier position encoding reimagines how transformer models encode position structure instead of treating positional information as an ordering mechanism. They leverage the mathematical foundations of Fourier analysis to simultaneously capture the discrete particle nature of tokens and the continuous wave characteristics of their interactions. Okay, so let's look at this. Should we call this FOPE? I hate that, FOPE. Fourier position encoding models each dimension as a Fourier series of different frequency components, thereby separating information more effectively and mitigating spectral damage. Inadequately trained frequency components are also clipped as their harmful influence on spectral. What? Inadequately trained frequency components are also clipped as their harmful influence on. I feel like the sentence is not finished. Let's see if we can understand what they're doing from the diagram. If not, we'll have to go into the text. So we have the rope described here, where they say we treat each dimension as a single frequency function, which they say is inadequate, which is, fair enough. The way that I would normally expect to see this math written is in terms of the rotation of the query and the key, but that's not exactly the way that they've written it, and so I'm trying to understand exactly what they're getting at here with the way that they've represented it. It looks like the main point of this whole panel, though, is to describe what they define as spectral damage. So in their formulation, they say that they treat each dimension as a multi-frequency function. And in the bottom, they're describing the undertrained frequency components. So we can have our different. No, I think. Oh, adequately trained frequency, floor frequency, adequately trained, undertrained frequency. Okay, so these are 3 different frequencies. And when you simply apply rope, you will get like weird pattern distortions whenever you have an undertrained frequency. So out of domain on length extrapolation, which deteriorates the periodic extension, that's true. You have to kind of account for your lengths before you start. Like technically you can change it after the fact, but that doesn't always perform well. And so they're saying to zero out the undertrained frequency components. They just clip those. Are they saying like, is this like they would use it up to the length and then they would trim it? I guess that's why they would call it clipping, right? I kind of want to look at the more specific math on this, or I don't know, maybe this figure is going to be helpful, but I am, as I scroll, looking for where they like cleanly define the formula for Fourier. Okay, I'm in the section called Fourier position encoding. I'm not getting a clean formula. That's awesome. I mean, this kind of is a clean formula, right? If I could just remember exactly what, in the context of rope, uh, exactly what the H is supposed to convey, and exactly what that's not a W, but exactly what that's supposed to convey. Architecture and subsampling mechanism of the time series model. Input time series. Okay, so this is, I suppose we've handled the position encoding. Did we really? But now they're talking about how you encode the time series. So yeah, let's glance at that. Maybe I'll come back to the FOPE and try to compare it to a rope that's explicitly spelling out, the frequencies versus the other things, and maybe then we'll be able to like. Do we even have enough information though? So we know that they're clipping for undertrained frequencies. What else do we know about what they're doing? Treating each dim as a multi-frequency function. I mean, is that what it is? Is it a hack on rope where I'm just going to have multiple frequencies for each dim? How many different frequencies for each dim? Is it 2? Is it 3? Right, because these are just like arbitrary frequencies, right? Yeah, it's just arbitrary frequency. Like we've represented 2, but there's however many. Treating each dim as a single frequency function, but do we treat each dim as a multi-frequency function, or do we just give a unique frequency to every dim? Because that seems to be more how I'm reading it. Or no, is this a single dim? I need to see. I need like the if I knew top of mind and really understood like the mathematics of rope or even just basic positional encoding better, this I'd probably be able to reconstruct what this is. But as it is, I feel like every time I read this, I'm like having to remind myself what all the different variables are and how they interact, and then I have my own mental model of the parts that I think are important, right? Which clearly don't give me quite enough background to construct however they're actually computing things just from looking at this diagram of it. But in this case, I think we can understand this one, right? So we have some input time series. Where are we doing the position encoding? I suppose after the patching, right? probably after dynamic patching, because we go from dynamic patching. So we start with this time series, right, which cannot be fed to a transformer because it's just this continuous waveform. We do some kind of patching on it, which is dynamic somehow, which is illustrated here. And then we must position encode it, right? Probably. Or do you think we position encode it later? Like, well, we'd have to position encode the different components just to feed them to the transformer encoder here, right? But I assume that these time series embeddings, which are fed to the later LLM, are what get the FOP encoding. Or do we use FOP here? I don't know if I'm going to get that level of detail, though. Like, it's nice that they're sharing the details they are, but it does feel like this is sort of meant to obscure some level of detail. Or I don't know, maybe we're going to scroll and there's an appendix and it's going to explain all these things, and I'll sound really silly for saying what I'm saying right now. It looks like, though, the way the dynamic subsampling process works is we compress diverse inputs into reasonable length range. That's a little hand wavy. Okay, but we do some kind of subsampling. The active subsampling module is up here. I'm looking at it like backwards, obviously. It goes top to bottom. So we have some time series and subsampling rate, which we use to have a patching calculator, which gives us a patch size and a stride. And given the patch size and the stride, we will just pass over and kind of treat this the way we treat images, right? With image, the patch size is typically equal to the stride. In this case, if you notice, the stride is lower than the patch size, so we are going to overlap parts of the waveform as we encode, and I suppose that gives us something a little bit more reliable, right? They do say compress diverse inputs into a reasonable length range. I guess because that's what the patching calculator will do, right? It'll give us a stride and a patch size, which will give us some embeddings that are of some length that ultimately we can handle later. So that's this dynamic patching. It's going to give us some initial time series embeddings. We'll feed those time series embeddings through a transformer encoder, then we'll do pooling. The pooling makes me think we're getting another reduction. And then we'll have some embedding layer and then some CNNs. Since it's a time series encoder, and since it's like kind of a 1D signal, I would think that this would be like a 1D CNN, which just like we already have locality bias here when we're doing the patching and the striding because the stride looks like is less than the patch. So we'd have locality bias here, then locality bias there. But locality bias in this case is kind of always good, right? Because the original signal is continuous. We've chosen these arbitrary points to cut it. And so continuing to have like locality, locality, locality probably just basically helps us pretend that we treated the continuous signal as if it's continuous, which it is. So these time series embeddings, which would be discrete tokens for our model, would naturally have leaked information from the ones that neighbor them, right? That would be the effect of this subsampling. That would be the effect of like having CNNs here. That would be the effect of the pooling, kind of. It depends on if the pooling is unstrided, actually, then kind of the opposite of what I said. But they should have some relationship to the neighbors. And then I still don't quite understand the FOP, and I really wish that I did. Yeah, discrete particle nature of tokens and the continuous nature of the interactions, and then this is the diagram, and then I am totally lost. I am scrolling for a minute just to see if I can possibly get FOP details somewhere in here. So forgive me while I scroll. Hey, bro from India. Hey, Rehan. How's it going? Sorry I didn't read it sooner. I've been very focused on trying to get the core of this method out of here. Mainly FOP. I want to know FOP. It sounds cool, but I kind of feel like I would need to spend a lot of time with a couple different papers side by side to understand. And is that something I want to do right now? See, the risk of doing it right now is at this point I'm still assuming it's all my fault. But what if they really did just leave out a bunch of key details and this is sort of like a teaser, basically? Anyway, so this paper, it looks like the things that they propose are basically a way to copy their experts for expanding the size, and then a way to route and train a little bit such that the experts quickly become quite diverse, which allows us to scale up for trillion tokens. The way that their group router works, we can distribute the load so that we can fit everything for trillion tokens, and so that, not trillion tokens, trillion parameters, so that it runs quickly enough so that we don't go out of memory. And then we have FOP, and then we have this dynamic patching idea for input time series, like audio waves. If I can find the same notation in the original rope paper, I will totally try to see if we can figure out how FOAP works. Let me make sure I've got the right paper, and then I'll pull it up onto the main screen. Because I know rope, and so if we can get like that same kind of notation, I think I can make them line up. If I had a deeper understanding, I could probably do it without matching notation. Okay, so far there's no matching notation, right? And the other way, we had frequencies, and we had, which, by the way, frequencies, is that, I think I know what that is, but I don't want to say it out loud because that'd be embarrassing. Nope, it's not what it is. I want to use the right name. Wait, is that not a Greek letter? Am I just bamboozling myself? I'm not seeing it in my little chart. Oh, no, it's a lowercase omega. It's a lowercase omega. Okay, cool. My omegas, my frequencies. Okay, yeah, I'm not seeing anything in this that lines up in terms of the notation. Like, I want to see them define it in terms of H's, right? Like, they're not probably going to define in terms of frequencies because it's not like a big focus in how they do it. For the reasons that this paper points out, right? Wait, did I? Yeah, for the reasons this paper points out, I mean, with rope, you're applying, treating each dim as a single frequency function. But the thing that bothers me is I feel like even without fully understanding their method, I would like to understand how they avoid like coordinates, treating positional information merely as an ordering mechanism. I mean, is this misleading me because they still do treat positional information as an ordering mechanism, and they also like introduce more complex frequency components and like the frequency clipping, which helps deal with like dynamic length better? I don't know. See, without seeing the exact mechanism for how it works, I just don't know how far it's going to be from things I already understand. Oh well, I do give up though. I don't think I'm going to get any closer to what I wanted to know. And yeah, I'm just kind of mumbling and stuttering my way along. All right, so do I want to do one more of these, or do I want to do like the CV history working stream? Oh no, this isn't even this is just something I brought up for reference. Okay, let's do some computer vision working history. I said I would create a browser account just for this. I'm not going to do that, but I am going to switch to a profile I never use, which should have just like a little less personal stuff. I'm going to like double check that real quick. Yeah, I think what this has is pretty fine. So let's use this instead. And let's pull up, okay, how am I going to do this? I want to have like, here, let's edit the stream title too. I'm going to update the title. Okay. Planning like a history of modern computer vision type of thing. I'm going to take a bite of donut. So, okay. So instead of going over like papers I've never read before, the goal right now is that I really want to make a series where we go over the sort of like a modern history of computer vision, which means I'm probably not doing like canny edges, or should I do canny edges? That's an old paper. Can I even get the paper on open access? Probably somewhere, right? Oh, I can. No. This is gonna be like blocked, right? Because I'm an IEEE. They require me to pay. Yeah. Ooh, but Clemson University just has it. Yeah. Wait, canny edge detector was 86? See, maybe we need to cover this. Because when I learned CNNs originally, this is how they were explained to me. Like, we first detect like very low level primitives. It was basically explained that the model is detecting these low level primitives that it slowly builds on as you progress through the layers, and by the end it knows like, oh, it's a cat. Let me see if I can find one of those diagrams for you. Um, what would be a good paper for that? I mean, CNNs as DPMs would kind of go in that direction, but that is not what I'm thinking of. I don't think it has the diagram that I have in my head. What paper has that? It kind of shows how, like, maybe it was even a blog, like an old blog. Um, this is such a dumb search, but let's see how it goes. Um, cool. Are you gonna give me like a reference? Are they all gonna be recent? Yeah, those are all too new. Newer than what I'm thinking of for sure. This 2018 blog really isn't bad, and it might point me to the thing that I like. Ooh. Yeah, did this person make this bespoke diagram just for their answer on Stack Overflow, which has 4 votes? That would be crazy. Okay, okay. Let's see, let's see, let's see. Okay, okay, lower level. Um, maybe this is what I'm thinking of. This paper. Visualization of patterns learned by the lower layers. And yeah, oh man, do we need to know, like, if I'm going to talk about this, do we need to know signal processing stuff? Like, do we need to know Gabor filters and other, like, simple filters? Probably, right? Do you guys know Gabor filters? It's basically this. It analyzes whether there's some frequency content in an image in specific directions. Uh, one really hand wavy to think about it is it's almost like pattern matching this in an image, but obviously it's not, well, not obviously, but it's not necessarily looking for, like, you're seeing yellow, blue, yellow, blue. I mean, it could be looking for that kind of thing, right? But basically, like, if you were to multiply, like, let's say that the image does have this pattern, and you were to multiply this by the image, you would get really high values everywhere, right? Like, let's say this is very negative, this is very positive. Or no. Like, if you were to normalize your image between -1 and 1, and let's say this is also between -1 and 1, and you were to multiply these two things together, if you were to multiply this over the precise region of the image that matches it, the negatives and the negatives would multiply to be something big and positive. The positives would multiply to be something big and positive. You add it all together, you get some really big value, and that tells you, like, oh, this pattern is happening at this place in the image. That's kind of the general point of the filters. Gabor filters in general, the way I would describe it is they're just kind of fancier, which is why it's saying they're used for texture analysis. Like, this is, like, what's an example of a really simple filter? Let's see. Because I guess a very hand wavy to explain Gabor filters is they're just, no, like, maybe I'll get a little example here of an edge filter. No, no, no. Basically, I could get a very simple filter that's trying to detect a certain type of edge if maybe the entire left half of this is yellow and the entire right half of this was blue. And that would detect edges in a certain direction, right? Whereas if I were to rotate that 45 degrees, I could try to detect edges that go sort of in the other direction. Whereas this obviously is not trying to detect an edge, right? Except another hand wavy way to look at this is trying to detect a series of edges that are close to each other, maybe like the ripples on fabric, for example. But really, it's even more complicated than that if you look closely at the values, right? This is not like edge, edge. It's got more, it's softer than that, let's say. Me trying to do hand wavy explanation of Gabor filter. But I guess what it's saying is, like, what this is saying is that it's notable that Gabor filters appear only in the third layer. And so, like, here, this is a, let's zoom in more. These are what it's talking about. You can see this, this, whereas you don't see any of that in this layer. You see, like, just simpler filters, whole and then things surrounding it, or like 2 parts and then a third. It's not like these, like, like multi. Man, hand wavy explanation of Gabor, I feel, makes me sound very dumb as I try to say it. But I think it's decent to understand, and I believe that the point that they're making, but I should go to the text again because I've read this paper in forever, is that the lower layers learn general features, but textures are complicated enough to where like texture analysis starts showing up in the third conv layer. I think that's the argument that they're trying to make. So the first layers are handling things that are even more basic, like edges and holes, and then by the time we get to the third layer, we're starting to handle textures within our feature space. I want to see though if that's what they say, because I might be putting words in their mouth, and that's not what I'm trying to do. Visualizations of features from the first layers. Interestingly, the first layer of the network does not learn the usual Gabor filters, but higher layers do. What do they mean, usual Gabor filters? Are they saying that? Where's the first time they mention Gabor? Okay, they're saying the usual Gabor filters. What? That's like the first time they mentioned Gabor in the entire paper. Is this okay? So maybe there's an earlier paper, which is actually the one in my head, which this one is commenting on, and we should try to find that. How about something like before a certain point and after a certain point, like before CV before Linnet and after Linnet? I don't view Linnet personally as an inflection point. Mainly because if we want to look at a timeline, we have Linnet 5 in 1998, and we had Linnet 1 in what? 92? 88. Okay. Yeah, we're going to have Linnet from 1988 to 1998, but we're going to have AlexNet. Can we get a Wikipedia article for this guy? But we're going to have AlexNet in like 2010. And my personal computer vision before Linnet would suck. Like I'm just like I took a fundamentals course, right? Years ago, and haven't touched most of those things since then. If I even touched them much then, because like when I took my fundamentals course was like after this paper was out. Like we had ConvNets. So I finished my fundamentals course learning ConvNets. So I couldn't do a very good job with before Linnet. And I don't think Linnet is the inflection point. Like I'm not going to go after, like it's not like we hit 1998 and it's like, oh man, now there's like a lot of these deep learning papers. It's more like it would be Linnet. And then a few papers start messing around with big data. We'd have to pick one. Somewhere in there we have Hog. When was the SIFT paper exactly? When was this? 99? Wow, I always forget that SIFT wasn't after 2000. But like maybe we have to do SIFT, right? Because if we're gonna do Hog, we kind of have to do SIFT. I kind of want to do Hog. Kind of want to do Hog because I do kind of want to explain CNNs in terms of DPMs, which means you have to know Hog, which means you should know SIFT. And obviously, at some point, Linnet or something similar to that has to be in there, because it's not like I'm gonna rock up and say like, oh, like AlexNet invented convolution, right? Because it didn't. I don't know. I wonder, these aren't things that you pay attention to as much at the time, but wait, was this a main conference? Because like it was a challenge. I wonder how the paper was technically published now that I think about it. Anyway, here, I accidentally closed chat somehow. Am I live? My window crashed. Have I been live this whole time? My stream chat window just straight up crashed. Could you hear me that entire time? That's crazy. Okay. Yeah, sorry, the window crashed. That's why I looked so discombobulated for a bit. Hassan Rans asks 2012 AlexNet. Yeah, was it 2011 or 2012? I guess it was published in 2012. When did they actually submit to the ImageNet challenge? It was the 2012 year, right? that it was submitted. Yeah, so like where does AlexNet want to tell me that their CNN is from? Like who do they attribute as the main inspiration? That might be a good way to, because it's hard picking the paper, right? Even picking AlexNet feels a little bit controversial because we do have like this paper. This is the Schmidhuber blog that explains how the revolution is triggered by DanNet. Yeah, winning 4 big which competitions did it win? Yeah, we could spend time just on this blog alone. Like who is Schmidhuber gonna give CNN credit to? Like obviously he's saying his DanNet was the first to succeed in big data, and yeah, he says AlexNet joined the party. It's funny to say it joined the party in December 2012 because I'm pretty sure it had submitted to the ImageNet challenge before the publication December 2012. I do also like our Deeper Highway Net and its variant ResNet. Anyway, this blog is a treat, but what is he going to say? Okay, this is going to be, no. What's his first CNN paper going to be? Is it going to be this one? See, like, do I start with Lynette or do I start with what Schmidhuber tells me CNN started with? Is this going to give me the PDF? Awesome, it's going to give me the PDF. Check out these diagrams. I mean, that's totally a CNN. The notation might confuse us a little bit, but this is what a CNN is. Or what? How much of our vocabulary is this paper even going to use? Like, can I get convolution mentioned in this paper? Probably not, because we're kind of abusing the word in the first place, right? Like, they're correlation filters. So can I get correlation in the paper? No. Oh God. See, this is why, okay, like when I actually record this, especially when I'm doing some of the older papers, I will need to prep really well. Because I am accustomed to looking for certain notation, and I'm not going to get that here. I'm going to get other notation. Like, I don't even think it's going to talk about them in terms of kernels because, like, we being the computer vision community, appropriated a lot of that language from image graphics. But I don't think there was a whole heck of a lot of image graphics going on before GUI. 1980s. So anyway, this is a paper to think about. First, Lynette is obviously a paper to think about. Then there were a bunch of follow-up, like Fukushima had a follow-up, and then there's another paper also before Lynette, which does backpropagation in a 1D conv architecture, right? Because these are pre-backprop, both of these. So this would have been like more like self-organizing maps. There would have been no backprop. So I would need to like brush up on how those work, like self-organizing maps. Is this pre-Boltzmann machine? This might be before Boltzmann machine. What year? No. Boltzmann machine's older, right? Not by much. Not by a lot. Does this mention that? Do we get it? Nope. Oh, wait. Let's look it up in terms of their, like, Sherrington. Okay, does this cite? No? Is it even relevant? See, this is where I get, like, so... Let's see, what else would I think would be relevant here? Self-organizing. What about map? Do we talk about... No? Man. Okay. Yeah, I would need to do a lot of prep if I was going to explain how this is, like, the CNN paper somehow. And I don't know if I want to do that, like, because I am kind of focused on, like, the origins of, like, deep learning computer vision. Is this the origin? Maybe it is. Anyway, I am curious. I said I was curious about what AlexNet says CNNs come from, right? So let's try to focus a little bit more on that. You were going too deep? Yeah. Yeah, that's the feeling. I do think chances are I start the series on Lynette 5. And then I just time skip, basically, to something that I think is important to understand the rest. If I did Sift, Hog, DPM, I might do them all in one video. And it would just be to set the stage for how we were thinking about CNNs when we were first building them. Okay, let's keep looking there real quick. I want to jump to something else, but I do want to finish the thought that I had which is who, like, when AlexNet is talking about their CNN design, what are the citations that they're going to throw on that? Okay, so they're going to mention this paper, which I wonder if I know that paper. We'll go click on it in a minute. What else are they going to mention? We can just look up CNN, we can look up convolution, and we can see. Okay, lots of papers. Lots of papers. I'll write these down on my other monitor real quick, and I'll make sure that I glance at all of them. So we're looking at 5, 11, 13, 15, 16, 18, 22, 26. Let's go check those out. High performance neural networks for visual object classification. Oh, one of the Schmidt-Huber papers. Okay, so that's cited. What year? 2011? Could that be DanNet? Did they actually cite DanNet? This has to be DanNet, right? I'm not going to try to pronounce the last name because I'm going to mess up the special thing on the S, but this would be DanNet. When did they start calling it DanNet? Does the paper call it DanNet? No, the paper doesn't call it DanNet. Is this two papers or is this the... Oh, it's like no, it's just a cover sheet. Okay. Okay, so AlexNet does cite this paper, which Schmidt-Huber complains is the paper, right? Which I think was never called DanNet. I don't know, actually. I'm not going to say that. I don't know enough. They didn't call it DanNet in the paper. AlexNet is AlexNet in its own paper. I do wonder if Schmidt-Huber mainly did that as a reaction to the fact that AlexNet was called AlexNet, which made it kind of memorable, right? Like, that's good for branding. It's funny that people don't do it more. Like, Transformers aren't, like, IlyaNets. That'd be pretty funny if they were. Let's see. Jan LeCun hosts this PDF. What is the best multi-stage architecture for object recognition? Okay. So we get a LeCun paper. We get one of Krzyzewski's earlier papers on conv networks for CIFAR 10. Whoa, on the 1.6 million. This is the tiny images that I was showing you earlier, right? Do I have that open still? Or did I close it? If I closed it, that's lame. Well, no, that's 80 million. Where does what's 1.6 million? He mentions that so casually. Which data set is you referring to? I should know this. Not that I'm this old, but okay, two subsets of 80 million tiny images. Great. Okay. See, this is part of why I think this paper is so important, because this one. Because like before the GPUs got a little faster and before the architectures got a little bit better, this started kicking off a lot of the training deep networks at scale kind of thing, right? Like training on 1 million ImageNet images may have seemed crazy, but like training on 1 million of these tiny ones, that's a lot more palatable. So I kind of do feel like this is a paper that belongs, this one specifically. But doing this paper and not doing like, what's the name of the data set? Are these search terms that are going to get it for me? Because this one's from way back then too, isn't it? Like, isn't this going to be, what year? Am I going to get a year on this guy? I mean, maybe if I take the title into Scholar or something, I can get the year. 2010. Lots of these around the same time, right? Was it on, like, was it published somewhere even sooner than that, though? No, it looks like just 2010. So I don't know. We got this guy in like, I feel like this one's 2008, but is that actually wrong? Was this not 2008? Let's, I guess do the same thing we just did, right? Search. I mean, this is when it's appearing in the journal, so it obviously exists to be, okay, it is 2008. Like, I don't know. Can you guys think of a data set? Like, oh, okay, obviously we could start with like ImageNet instead and just sort of like, but I feel like part of the unique thing I could bring to this discussion is like everybody knows ImageNet, everybody knows AlexNet. I think it'd be kind of nice to talk about this interaction here, right? Where this tiny million data set existed. Kruszewski was validating some of those CNN ideas on this data set. And that was an important precursor, I feel, to let's wire the two GPUs together so I can process this whole data set. Okay, let's see what other papers we are saying are important. I've got a couple of other ones. Is this? No, where are we? Where did we go? Ah, here we are. Okay, so we looked at that one. Let's grab. Oh, okay, this is just Linnet 2? Linnet 1? Linnet 2? Let's see. Did he even call it Linnet in the first paper? I don't think he did. Which makes me think this is Linnet. No, this is Linnet 2, probably. Okay. I would guess. I'm pretty sure it's Linnet 2. Okay. In our undergrad course of CV, we study Linnet 5, AlexNet, VGGNet, ResNet, UNet. Yeah, those would all be pretty standard. Some of those I think are not things I'm going to cover. I really like the ResNet paper, so I probably cover it. I don't think I need to cover VGG. I like the UNet paper. It's pretty straightforward. I don't know how relevant UNets are right now in this moment. I think they're still very relevant if you're in like medical image, but with diffusion models, at least right now, we're really just using transformer architecture. And we use VAE, like we use autoencoders, but we don't necessarily need the connections across resolution bands. And that's like the big idea with UNet. Like obviously I could talk about UNet, but the question is just like, there's some balance on this series where it's not just your undergrad computer vision course, and also where, I don't know, a lot of it is my taste and in picking the papers that I think are important to understand what's going on right now. Like I could cover every Linnet paper, or instead of Linnet 5, I could do a video that is Linnet papers, and I cover all of them, and I do my homework and I prep it good, and I can cover them all sort of in one go, and get at like basically what I think they're contributing and why I'm even talking about them in this series at all. Which advanced / latest topics will we cover, like VAT, etc.? Hassan, I would like to take the series all the way up into the present moment, basically. I'll tell you some of the modern ones that I like. So obviously we're going to have an image is worth 16 by 16 words, right? To have an image is worth 16 by 16 words, we need to... I don't know if I want to cover this. There's so many videos on this. There's so many videos on both of these, but like these are papers that need to be covered, right? Other modern-ish stuff, like I think for me, modern CV starts with this paper. I'm also very partial to like, I'm very partial to this paper. It's contrastive learning. It beats Big BIGAN, and it technically, I think, was published after MoCo, right? The timeline with SimClear, Perl, and MoCo always confuses me. And the problem with those three papers is I feel like I barely even need one of them, because the thing that I really want to cover is CLIP. So CLIP's going to be in the series. These are, so like, here, we can almost organize it in terms of papers that I know I'm going to have versus papers that maybe I have, right? We're going to have VIT. We're going to have CLIP. Probably we need to do transformer because otherwise the other stuff doesn't make sense. And we are going to have ResNet, right? So like these four here, we can put this here. These are papers we're just gonna have. What else are we just going to have? Picking a diffusion paper is hard because it's like some of the earlier, like not earlier, but like some of the image diffusion papers almost don't, like it's like they didn't know they were what they were. And so like I would love a paper that really cleanly presents, like here, let's see if I can find the repo. ADM UNet, GitHub. What's the right thing to search for this? It's basically the first repo. I think it's an OpenAI repo. No, it's not ADM public. Is it just guided diffusion? It might just be guided diffusion. I guess it's this paper, right? Yeah, it's just the Daria paper. This paper I think we cover. Yeah, I think this gives us diffusion just fine. I need to pay attention and be careful that there aren't papers just a little bit before it that are giving quite a bit of juice too that are being ignored. But we do this. Oh, we also do. Well, here's the thing. I don't know if we do this. Okay. I can come up with reasons to do this and reasons not to do this. Reasons to do this is just famous. Reasons not to do it are that like we don't really generate images with GANs these days. Reasons to do it are this core concept of like discriminative generative adversarial learning. It still happens a bit and still pops up quite a bit. Another reason to have it is I'm not 100, like it's obviously really hard to comment on people's closed source models, but for a while, some of the secret sauce in top diffusion models was that they would train the model, at least towards the end, with a discriminative loss. Like they would train a discriminator to give some GAN loss to their diffusion model. And this would also be really important for any of like the turbo diffusion models. Typically, the way that you get your model from like 50 steps down to 8 or 4 or 2 or 1 are you take whatever the output is, you throw a GAN loss on it, and it makes it look just a bit better. I think I can even find an example of this. Is this gonna, yeah, accelerating emo diffusion models with backward distillation. So like the core idea of this is supposedly backward distillation, right? But one really key thing that they're going to do in this paper is, please tell me that I'm right, that this is one of the ones with the adversarial loss. That would be really embarrassing if I'm misremembering that. I just need to find, so okay, they do use the adversarial loss. Great. Where is the figure where they show how important it is to use the adversarial loss? ADD images are more crisp than those generated by step distillation LCM. Due to these some I see. So they're saying the reason that these look so crisp compared to the others, like if you compare it to the step distillation, these look very crisp. Like compare is this a pagoda? Compare this building to this building, you'll see it's crisp, right? Everything's crisp. That's an adversarial loss. That's what you get from adversarial loss. And so it's common. And yeah, interesting. But imagine Flash gets even more sharp compared to ADD. I wonder why. Anyway, basically GANs remain important because you can still throw a GAN on top of a diffusion model to potentially improve the outputs. And the idea, I feel like, just always comes back in some flavor or form. But I don't know. I don't know if we do GANs. It's sort of like, I don't know if we do UNet, right? Because like we've essentially stripped away a lot of these things, although it comes back sometimes. I'll show you. So like this is UNet, right? It's a lot like just an autoencoder. The big difference in UNet and just any downsampling channel expansion autoencoder is this idea of the copy, right? We'll take some of the encoder side maps and copy them all the way to the output. So basically our output is aware of the earlier layers. Some of the benefit of this is that you like preserve the high frequency information that would have been lost going deep in the network. And you need that high frequency to do good segmentation. Hypothetically, you need that high frequency to do good generation. It does kind of show back up though, right? Because like you have papers like this one, which basically takes a DIT and turns it back into a convnet. And I think I brought this paper up on stream a couple weeks ago even. Like, see, so we've taken, these are called deco blocks, and we can stack them like a transformer. They operate at 3 distinct resolutions, although you could change that depending on your target resolutions or whatever. And we do this concat operation. We have a concat and a linear. The main difference between this and a DIT, aside from the fact that we've done this downsample and upsample, we've shaped it in terms of the UNet, and we've done the concats. The other big difference is we've replaced the attention right here. Yeah, we replaced the attention. So instead of the self-attention, we have this conv module. So it's kind of like a local sparse attention. But it comes back. This is a UNet in many ways. And at least on ImageNet compared to DIT, this is, I want to just double check. Yeah, faster. Throughput's way higher. It's way faster. It's way faster. The results are better. So yeah, maybe you don't need the attention. You can have this conv sparse attention basically. And you can still do units. So I don't know. So that's the danger of skipping papers just because they're not currently in fashion. What about JPA stuff? I don't think I'm going to do JPA. Try to pitch me on why I would do JPA. Like, I think I'm trying to cover a history of computer vision as is necessary for understanding state of the art. And kind of JPA's whole gimmick is never being state of the art, right? Yeah, something related to video understanding would be cool. There's a paper that I really like. But I don't know if it's the right touchstone. I really like this one, though. I really like this Max Bain paper. There's a lot of good papers from Max Bain, by the way, for video understanding when it was still, when we were just barely starting to use big models to do video understanding pretty well. And the big idea with this model was that you could reuse other frozen models to do good video classification. Does the diagram really capture that? I think the text encoder was frozen, but the space-time transformer encoder would be learnable, right? That was the main idea. Oh, and the other idea was that it didn't matter if you did images or videos. You could pass them both through and it could kind of learn how to handle both. I think that encoder, though, is still initialized with, like, clip or something. I don't think it was trained from scratch. It's been a minute since I thought about this paper, though. Let's see, this is method. I would probably see that in implementation. Right, I think they'll comment the architecture in a minute, hopefully. If not, I'll just start doing crazy searches. The text encoder is a distill BERT. Yeah, BERT was pretty popular as the text encoders back then. What about the visual encoder? Did they train it from scratch? I don't think they did. I thought it was like a pre-trained clip or something. If they trained it from scratch, that's crazy. Because they didn't really have that much data. Maybe they did. Maybe they totally, yeah, maybe they pre-trained it ImageNet. And then they continued the training on CC3M plus WebVid2M, which I think CC3M was an image set. And WebVid2M would obviously be a video set. Am I remembering CC3M right, though? It's been a minute since I worked with these data sets. Did they just train it from scratch? That's crazy. I don't know why I thought they initialized from Clip. There was definitely other stuff that initialized from Clip. They probably even compared to it. Let's see. Yeah, ClipBERT. ClipBERT would have been Clip initialized. I forgot that they trained theirs from scratch, kind of. So I think this one's kind of important, but I don't know. Yeah, with video understanding, Hassan, the problem is just like finding the paper. Because there's so many of these other things I feel like you have the paper. Like ResNet is like whoa. The other tricky thing is like, okay, so talking about doing UNets or doing GANs, do I do object detection? And I don't know. Like, do I do RCNN? That's a lot of citations. It's important in like the history of computer vision. But I mean, you can go to workshops these days and watch talks from some of these guys that made these methods, and they'll be like, oh, object detection is a useless task. Oh, I wish we never even defined object detection as a task. So I don't know. I don't know if this is a paper I cover. It's tricky because this is like your heyday of almost fully empirical computer vision, where we would make these like super complicated pipelines, and it was really just based on whatever worked. but I don't know how relevant it is now. Understanding these ideas, I feel like, is helpful, though, from an educational perspective, but I'm not sure the extent to which it fits in our series. And, like, see, that's like, if object detection was still big now, like, if we were still really big on object detection, well, then I would have to do this paper, right? But, like, I think, obviously, I don't do it, because we don't really do object detection these days as its own first-class task, you know? Like, we have LLMs that can stall put bounding boxes, although we've even kind of moved away from that, because when you do segmentation properly, it kind of subsumes object detection. So I don't know. There are obviously still applications where object detection is relevant, so maybe we do it anyway. And, like, it would also be fun. It would just be fun to have a video on this paper, right? Because I feel like some people that maybe have heard of it but have never read it don't realize, is this one not as fun? See, maybe we just do the fun one, right? I know this one is fun. Sometimes you just kind of phone it in for a year, you know? I didn't do a whole lot of research this year. This is a paper with 40,000 citations. That's how it starts. I guess technically it starts in the abstract. We present some updates to YOLO. 40,000 citation paper. It tickles me. Another question, if you're low on compute, which subfield CV should you look into? I think you talked about this earlier. If you did, let me know. I'll check it out. There's so many. There's a lot. I have so many blind spots. I'm going to miss a lot. I think, obviously, there's whole like subfields where it's like at the edge computing, right? And that by definition is low compute. So, but some of that stuff is often relegated to workshops or ends up being more niche. There's also stuff like what I did during my PhD a lot, implicit neural representations like these. You can train Siren on a single like low-grade GPU, or even like if your laptop has an onboard GPU, you could train it on that because they're not very resource-hungry networks. What's like mainstream? The mainstream things to do when you don't have a lot of compute is to build benchmarks. And if you have a little more compute than the low compute, the thing to do is to like do some RL tuning or some fine tuning or some LoRa, right? Like if you have less compute than industry, but more compute than nothing, those are the things you do. And that can be anything, right? It could be LoRa for the image generation. It could be LoRa for something else. Oh, I guess Gaussian splatting is obviously not something you can run with no GPU, but it's less GPU hungry than some things. So there's Gaussian splatting, which is a lot of what 3D and 4D is right now. Also, something to do. So I talked about a lot of people do benchmarks. Part of the reason to do a benchmark is you can do a good benchmark in an area and show that you know the area, or like a good analysis type of thing, and then you get an internship that gives you the opportunity to have industry compute, and then you do a proper methods paper, and then it's this nice self-reinforcing loop. Now you're an expert, you can continue when you don't have compute to do the benchmarks, and when you do have the compute, you can, you know, build things, build models, build systems. So I think that's a bit of how it works. Yeah, this paper's just fun though. Like, look, their method is so fast that it's just totally off the plot. Part of the issue is, though, how do I talk about YOLO if I don't talk about SSD? How do I talk about YOLO and SSD without talking about RCNN? And then it's just kind of like... But on the other hand, there are reasons to talk about YOLO, right? Because I say object detection is dead. That's not totally true. Segmentation is kind of expensive. YOLO can be quite cheap. And so RCNN, heavy pipelines for bounding boxes, probably dead. But like lightweight stuff, YOLO at the edge, not dead. So I don't know. It's like maybe we do cover YOLO, but covering YOLO without the other things feels so weird. But I don't know. At some point, I obviously have to prune these, right? I can't do all these papers that we're opening. I don't want this series to be like a year-long project. I want it to be like a few months, where it's just like a video a week for a while. So it takes some thinking. Are you planning to cover Dino-like papers as well? That's a great question because I like those papers a lot. Why did I just Google Dino? Luckily, it has my search history, so it kind of knows. Like, I like these papers. I don't think there's anything that important in this paper, though. It's a powerful model. But what's the big idea here? And how did that, like, change everything? These features are really useful for dense tasks. It's a really good backbone for segmentation. And as they figured out in the later papers, oh, we'll pre-train on, you know, let's see if we can find the table where they describe the data. Boo-ba-doo-doo-doo. If we look in Dyna v3, they took the Dyna v2 idea to an extreme, right? It's like, well, why stop ourselves on millions of images? Let's carefully scrape and pre-train on. It's in the appendix. I should have just started in the appendix. It's in the appendix. Why am I here? I should have just started in the appendix. Why am I still scrolling? I should have just searched appendix. It's in here, right? That'd be crazy if it's not in here. We'll just go to Dyna v2 if they don't have one in this paper. Maybe they don't. I'm starting to think they don't. Do they really not? I may have scrolled past it. It's okay. From JPA earlier, I kind of meant self-supervised learning though. Yeah, we'll have something. The thing is, if we're doing self-supervised learning, picking a paper is so tricky. Like I said, okay, so you have here, I'm going to find this table I wanted to talk about, and then I'll talk about why I'm struggling with self-supervised learning. So the paper where they describe the, sorry, Caltech. That'll do it. Okay, no, let's do this one. Okay, so what I see as the big contribution of Dyna v2 is this. If I scrape a million bird images, suddenly I can do my test a lot better on bird images. And who knows, maybe the data even leaks, right? If I scrape a million kitty-like images and a million NYUV2-like images and a million sun-like images, I'm going to do better on, you know, the thousands of kitty and NYU and sun images that actually exist. So, yeah, I don't know. I appreciate the idea of Dyno for what it is. Like, I appreciate the self-distillation idea, but it feels a little more self-contained to me than other things. Whereas you had like this paper and this paper and this paper, which I feel it's hard to give credit to any given one of them because I feel they were fairly contemporaneous to each other. Like this one hit arXiv February 2020. This one was 2 months before that. This one was 1 month before that. I don't think these people were talking for the most part. I think that like Ishan and like Kaiming and Ting, like I think these were mostly like the same really good idea at the same time. Which paper's the one I spotlight, or do I try to hit all three? But like they're papers with a lot of ideas that I like to talk about, and so like how do I even hit all three at once? This is what I like to hit though when it comes to self-supervised, because I view Dyno as downstream of that, and I don't view anything else as downstream of Dyno. But do I hit Dyno v3 as sort of like the state-of-the-art for encoding dense features? Maybe. And maybe that means that I do hit Dyno because it leads to Dyno v3, which is a state-of-the-art for many, many, many things right now. I'm not sure though. It's something I have to think about carefully. And it's also like, to what extent do I cover things that were very, very famous at the time, but now are viewed sort of as like detours almost, right? Like this paper triggered within self-supervised learning a paradigm that died as soon as we figured out VLMs, where they were like, okay, previously in self-supervised learning, the thing that we're trying to do is get good features. What you'll notice about this paper, though, is when they try to do linear probe of these features, it's not very good. I don't know if they even bothered to put it in a table where they compare it properly to other methods. We can see. These are going to be, no, these are fine-tuned. Do they even bother to give us that table in their paper? If they don't, I'll just show you the number in a separate paper. It might be in the appendix where they actually give the number. Yeah, linear probe compared to, okay. Well, they compare to the BEAT and the IGPT. Those are like kind of similar things. Do they compare to the SOTAs? I don't think they do. So when this paper came out, if this paper was a couple years earlier, even this 73.5 linear probe would have been groundbreaking, right? But at the time that this paper came out, which I need to be very careful about the years, December 2021, I think we already had this, which I think I could be messing up the years too. Like we could have already had Mocha V3. Yeah, this was a little update. No, I'm getting the wrong paper. I know where I might get the right one. VISSL Model Zoo. This is gonna help because it's gonna have tables that give the numbers, and you'll see what I mean. Or was it just better even on Linear Probe, at least for a minute? BYOL was stronger, but I'm not sure. I mean, we'll look at the timing on BYOL. Oh no, SimClear V2, even 80. Yeah. Deep Cluster, okay, Deep Cluster V2. This is the one where I think it's after MAE though, right? I feel like this was, no, this was 2020. Okay, perfect. This is exactly what I mean. Okay, so this Mathilde Caron paper, which Ishan was on that paper as well, by the way. So look, we have Ishan with Pearl, PIRL. We also have Ishan again on this one, which this paper was two things. A lot of people remember it as the Suave paper. It was actually also the Deep Cluster V2 paper. Because Deep Cluster V2 was just their attempt to give a more fair baseline. Because this method Suave was just very powerful. And this is even training small batch things. So 74.3 became their number to beat with a ResNet 50. And then they improved the Deep Cluster V2 to 74.3, so they were getting a lot closer to the supervised number, all of which were better than anything that, if we can find my tab, much better than anything that this paper was ever going to get for the linear probe regime, right? But what this paper said is, what we give you is not a good feature. Well, we give a good feature. It's a good feature. We don't give you the best feature. But first off, we have a trick that makes it a lot quicker to train in the transformer style, which was new. If you notice, those other papers I was showing you were ResNet, right? This is transformer. So first off, we're going to show you how to train efficiently with these VITs, which were still new at the time. And second, we're going to show that it's not about getting a good feature, it's about getting a good initialization. So you can do this pre-training to get an initialization, and that initialization, once tuned, will actually beat supervised. Like, blow it out of the water. Totally crush it. And this was a pretty persuasive idea at the time. And for a minute, it felt like we kind of abandoned the whole, like, learn good features, which we can then use on downstream tasks kind of idea. And instead, it was like, let's learn a good initialization, which will then fine tune on the big task or on the little tasks or whatever. So a shift kind of away from features and towards like the model and its weights, its initialization itself. So we had self-supervised learning for good feature. Then we had self-supervised learning for good initialization. Where this kind of died was, I need to find the exact paper actually. It might be this paper. This is certainly the one that comes to mind first. But this paper shows you can plug the vision encoder into the LLM and you keep the vision encoder frozen and you can do visual question answering. And this kind of kills MAE because first off, MAE is vision only, whereas here it could use like a clip, which is already aligned to text. And second, this model's like, I give you a great initialization, please train me more. And the other models are already ready to go. And we didn't really like tuning the vision encoder in our visual instruction tuning, right? We want to train the alignment and then maybe we'll full tune the language model. But that vision encoder is a part where typically if we touched it, things just got worse. And so stuff like MAE that says touch me, and systems like this where it's like we actually can't do anything to the image encoder, I feel like really brought us back into the regime where we are like, okay, we need a good model which generates good features, which we can use in the VLM. So it took things from before it was like people saying we need good features. We're like, I need good features for my niche downstream task. I need good features to classify birds. I need good features to do depth segmentation on some stuff that I don't have a lot of data for. Well, these guys are saying, just get data and tune it, obviously. And this said, well, hold on. There's like another reason we wouldn't want to tune. There's another reason we would want good features just coming out of the model already. Once again, sorry. These are good features, but like the best features for this. Is this the paper that introduced VLMs? I'm not sure. See, that's why I need to do prep before I properly record. Because off the dome, there was a lot of stuff going on in the summer of 2023. A lot of people were racing towards this idea at the same time. And I don't know who was actually first. But this was almost certainly the most memorable paper that figured it out. I think this paper also introduced the very simple fusing layer, like the projection W. Did it? Because this idea, like the projection W, is more familiar to me as Q-former, which would have been blip2, which would have been when? I don't want a video on blip2. Way before. So maybe this is better to say it introduced it than like Lava did it better, right? Lava does it better. Well, and what Lava enables, no, I think Lava just did it better, right? Because yeah, blip2 is clearly earlier. Q-former was earlier. That's why I said I recognize the projection idea more as Q-former than I do as like their projection, right? They kind of take that from blip. And they certainly were aware of blip2. I think the main thing that was different about this was the training process, which is why, I mean, they call it visual instruction tuning. It was the idea of how you connect them. The idea of the alignment step where you just train the projection, followed by the full tuning step where you mainly focus on having like the high quality instruction data. I think that was the big difference between these two systems. But I would need to like reacquaint myself with that, right? Because this isn't about like at the time that I'm living through this, you're just trying to like process what each thing does. But now if I'm going to do good videos on it, kind of need to reconstruct that more precise history. And obviously Lava was better than Blip. I think a lot of what they solved though was the data and the training recipe, not so much the design, because the designs were very similar. Yeah, that's a good point. It is simpler than Blip's Q-former. And I think a big difference here is I believe that the text never goes through the projector. Whereas Blip, part of the idea was this is how you unify. It was like, oh, well, you'll do some simple like text-aware processing of the queries before you get to the LLM. Whereas in this paper, it's like just doing the LLM. And obviously in Blip, I think you're never touching the LLM. Whereas this paper gives you a way to actually train the LLM in a way that's like productive, right? So we get a step further. It's like here we can train the Q-former. Here we can train the projector and the language model both. Um, I think it shows that if you train a very good text model, VLMs work. It's like a proof of scaling for VLMs. Yeah, it's a proof of scaling some parts. I think it also sheds light on even like it points towards how unsatisfying this part is. And this part remains very unsatisfying. I think it really bothers me with vision encoders that as time goes on, not only do we not figure out how to scale them up, if anything, they get scaled down. Like how many parameters Qwen3 VIT? It's like 400 million, no? The VIT part. Can my AI summary get me the Qwen3 image encoder? Why not? $543 million parameters. Yeah, based on a relatively small siglip. It's like they just get smaller. They don't get. Not only can we not figure out how to scale, if anything, it's like we're just going smaller. Which, okay, like should your image model just be a big thing itself? Probably not, right? Like if you're trying to model off the human brain, we need to see, but then reasoning happens kind of integrated, right? So it's like we probably don't want to waste tons of parameters on the vision part. But on the other hand, it feels really unsatisfying that it seems like the good thing to do is train like a pretty small vision model and then just like leave it alone. A lot of papers do push this forward a bit, and I could cover some of them another time. But I do still feel like we're broadly stuck at this point where language models get bigger and better and smarter, and the vision model's just kind of there. Papers like LIT show that if you freeze image encoder, you actually get better results. Yeah, they just don't touch the vision part. Yeah, at least big groups, it feels like. I mean, I think you can get folks at Anthropic and OpenAI even saying like the vision part is solved, which obviously is not true if you look at the broad spectrum of vision tasks. And when better vision encoders do come out, models do, take them in and replace them and typically get better results, right? It's not like Qwen is using a clip, right? They're using Like if we open, like if we look at this again, dang it, here Qwen3VL, like the vision encoder is like it's a fancy vision encoder. I want to get a year on this. Like, so Qwen 3 was 2025, Siglip 2, like this paper was also 2025. I mean, so they're picking up the latest and greatest. This specific architecture is even like we observed that you can go bigger than the L, but H might be kind of wasteful, so we made something just a bit bigger than the L, right? And they even, I think the Qwen one is a bespoke version of this because it's not 400 million parameters, it's like 500 or so million. So we learned more about what good vision data looks like or how to scale the data. We learned a little bit more about the model design, and we've been tweaking lots of things the whole time, right? Like we learned how to take rope into the VLM natively, and like taking the QK norm. And like Donna V3 has this idea of rope jittering that tends to be good for being more robust to like large resolutions. And so like there's things that are getting better on the vision side, but it obviously isn't the same as all the stuff happening on the LLM side. Um, Eyes Wide Shut that shows failure cases of vision. What kinds of problems do you think vision encoders still have? Eyes Wide Shut reminds me of a movie, LOL. Yeah, I'm not sure how outdated. Let's just look at Eyes Wide Shut. Um, how? Of course we get the movie. What am I doing? Eyes Wide Shut archive. Um, yeah, what problems? Which of these are still relevant? Let's look. Chirality, I guess, was one of the problems they said. The dog is facing to the right from the camera's perspective. Is the dog facing left or right from the camera's perspective? Um, I feel like that's a sucky question, right? I'm not sure how I'm meant to answer that. Like its face is looking one way, its body is fully pointing the other. I feel like sometimes when people do these, I'm like, I think that question's ambiguous. Um, I don't know. I'm not a huge fan of that question. I don't think if you properly constrain this that this is an issue still, and I'm not even sure if it was an issue at the time. Like I think that this is arguably a fine answer to the question. Do you see any windows in this image? No, there are no windows visible. Ah, okay. I think part of this, I would need to overlay a grid on this to be sure. But when you're processing, like if this was, this is a GPT-4v, I don't know what vision encoder GPT-4v was using, but if your patch size is large enough and your model is not trained on a lot of data at the proper resolutions, like this window gets really, really small in your patch space, and so it gets missed. That's still going to be a failure mode of the way our vision architectures work these days, where as long as the thing that you're talking about is tiny enough, it could get kind of washed out in the way that the model patchifies things. Especially if, like, let's say that the thing you're talking about occupies like maybe a 4x4 grid of pixels, which is like 1/16 of the 16x16 patch. It's obviously not going to get good vary representation in the feature space. So stuff like that is always going to be somewhere on your failure boundary, right? Until we change the architecture to where we're not just like blindly patchifying stuff, uniformly patchifying things, or maybe not patchifying at all. Is the door of the truck cab open? Um, is that a door? I need to zoom in to see this one clearly. I mean, it doesn't have a door. I think though, like I've thrown images like this at like top proprietary stuff recently, and it'll say like if it's kind of confused like me looking at it, it'll be like, well, there is no door. Maybe it would describe this white panel. I don't think it would miss this question. The image shows one eye of the animal. It's a close-up of a bald eagle. I'm considering logging into my ChatGPT on this so we can actually just throw these images and these questions at the big model. The only problem is in the sidebar of my ChatGPT, I have all of my conversations, and I don't have like super personal stuff there, but I still have stuff I'd rather not stream, which is the reason I'm not doing that. Will Gemini let me throw images at it? We can see. Um, I'm not sure if it lets you throw images at it in the free tier, but we can try. Let's try to blow this up a bit. Let's grab a screenshot. Is the door of the truck open? I think it's gonna nail it, but we'll see. Something went wrong. Try again. What? What's going wrong? Maybe I just don't have this tier, or maybe you have to be signed in. Here, let me try to do it on my other monitor, and I will just tell you what happens. Is the door of the truck cab open? It says, yes, the truck's cab door is open. You can see it swung outward on the driver's side. Is it right that that's the driver's side? I don't know enough about whether the image is flipped or not to know whether that is the driver's side, but I'm going to say that that's the free version. Messed up reasoning, nailed it. Okay. So the vision model gives enough that the reasoning model can figure it out, right? In this image, how many eyes can you see on the animal? Yeah, it's not going to mess up eye counting these days. How many wheels can you see? Counting is mostly not a problem from my experience using these, and I'm not going to even throw that at them right now. Like maybe counting once you get above like 4 would kind of suck with some of these, but a lot of them, especially if they're in reasoning mode, they'll be able to count just fine. Is the school bus parked facing the camera or away from the camera? Well, okay, and also, if you're talking about the vision encoder, I don't know if it's the vision encoder's job to count, right? It's simply the vision encoder's job to present features to the model that the model can then process and count. Are the butterfly's feet visible? That's another thing. I don't think vision encoders were really messing that up even at the time. Like, even a clip model, I think, would give enough feature to where a model, if it could process it well, would say feet. The thing you are going to struggle with, even in modern multimodal LLMs, is something we've seen in the papers we've looked at recently, where they do have a bias to try to ignore the image features when they perform the attention. The model just kind of doesn't like them. It's almost like a familiar way I'd say it is the models have an allergic reaction to image features. It's like, I know text features. There's this foreign thing introduced, image feature. You're sort of forcing me to attend to it, but that's not, I'm a text model. That's an image thing. So that's where you might run into trouble. Like, vision encoders can handle this. Can LLMs like interact with those tokens well? Maybe not always, even still. But I bet most of them would be fine with that. Is the school bus parked facing the camera, away from the camera? I would be shocked if any proprietary thing fails that right now. Feel free to screen cap it if any of you want to. I would be really, really, really surprised. I'm not even going to bother. Is the edge of the heart in the picture white or dark colored? They're not going to miss that. From camera's perspective, is the piano back panel on the left or right side? They might miss that. I mean, directions are still kind of tricky. Even I have to think about it for a second. Like, is the piano's back panel, I guess it's on the right side, right? I'm looking at the image. The back panel is somewhere over here. That's the right. That's a kind of complicated inference. I'm sort of curious if one of you wants to screen grab it. Feel free to let me know the result. But again, is that a vision feature thing? No. So these are obviously mostly like failures of the LLM to interact with the vision encoder, which is mostly about the way I initialize my language model, the way I initialize my vision model, which typically it's pre-trained, right? And then the way that I plug them together, and then the data that I use to like do that tuning process. That's what I think most of these failures are going to be focusing on. And hold on, I think my wife is trying to reach me. Give me 1 minute. Okay, I'm back. Yeah, I don't think, like, I think this is mostly not even exploring failures of the vision models at the time. Perhaps this one could be one example where the vision model itself is failing. Most of these are failures in the plumbing. And so let's see what the original question was. What was the original question? What kind of problems do you think vision encoders still have? Okay. Oh wait, can you provide any example to this? Sorry, Hassan, example for what? Like examples of it answering these questions, right? Or just clarify, examples for what exactly? And to answer the original question, what kind of problems do I think the vision encoder still has? To be clear, I don't even think it had these problems at the time. I did say one of the problems I think it still has is, like, if things get low res enough within the image, like, low res enough. If something is small enough in the image, I think it could be missed. And then, I mean, the models will do better and better the more that you throw representative data at them. So like pretty much any of them are still going to struggle if something they're trying to encode is truly out of domain. And so the solution to that, if you're looking at something like SIGLIP, is to train on 50 billion images. There's also weird stuff where if you ever train a model at the billion image scale, you will look at the captions you scrape and you will be like, oh my God, these are terrible. And your gut reaction will be to try to recaption them with the VLM. And you'll look at those and you'll be like, these are way better. And then you'll train that model and it'll perform like 10% worse on every benchmark. And you'll say like, oh, what the heck happened? Somehow the way that like CLIP, SIGLIP work, they live in the dirt. Like, even though some of the captions are straight up wrong, it's either the wrongness that's helpful, or perhaps it's just the naturalness and the variety in the human text that's helpful. But either way, it is simply better to train with 50 billion noisy captions than it is 50 billion synthetic but correct captions, which is kind of weird. But perhaps part of the reason is because that captioner will fail on all the failure cases, and so you'll simply never get any coverage of them working well. And so you could inspect 100 images and see 0 of these because it's a failure that appears in less than 100, or like it takes more than 100 images to see that failure. But over the course of 50 billion images, your model would have had maybe 1,000 chances to see it, and now it's going to fail every time in that case. That's like one hand-wavy idea I have for why you can't recaption. But I think that is still something that's sort of unsatisfying, is like, why, even when I have very, very fancy pipelines for the synthetic, why does my CLIP and my SIGLIP seem to be allergic to synthetic caption? That's, I think, something that kind of bothers me a little bit. Is that like a shortcoming of the final model, though? I don't know. And so, what do I think is the shortcoming of the current vision encoder? Oh, I'll say, okay, one thing that I think is a legitimate shortcoming is that we have one type of vision encoder, which is good if you want to generate, and then another type of vision encoder that is good if you want to understand. And for me, it is very unsatisfying that these are still separate, especially because we can find tasks and paradigms where those two clearly scale together. Like I've run experiments myself where I train like some kind of DIT, and if I take a bigger DIT and I take its features for classification, I get better image accuracy than I did with a smaller DIT. I also obviously get better generation. So it's like these two things scale together. They can scale together. The better generation can lead to better classification. So why can't I have a state-of-the-art encoder which generates both sets of features really, really well? Especially because these days, a lot more of my VLMs want to be like this one, right? My VLMs want to be models that can take image, take text, generate image, generate text, right? Well, in that case, well, here's what they do, right? They have an understanding encoder and a generative encoder. This to me is incredibly unsatisfying, and I would say this is the key shortcoming, or rather, the key shortcomings are understanding encoders don't generate good features for generation, and generative encoders don't produce good features for understanding. Unifying them properly should hopefully improve them both, but that still remains, in my view, an open problem. The closest thing you'll see to a solution of unifying them that actually works is, you can see it both ways. I think this one works better, where you take a generative encoder, like some kind of like fancy VQGAN, and you tune it to like behave like a CLIP. On the other direction, you'll see people take a CLIP and they'll tune it to where you can decode the tokens. Neither of these, I think, are SOTAs for understanding. Neither of them are state-of-the-art for generation. So still that remains kind of unsolved, because I think that your ideal true vision model can just do both things because they're both vision. To generate a great image a model should understand the image, and vice versa. In embedding models, I think they still use an embedding model with bidirectional attentions instead of LM with causal attention. Yeah, we process images mostly not causally, right? We process them bidirectionally. In generation, that's a big question too with images. You can see some methods that generate the video with the full bidirectional attention across all patches of the video. And then you can see like autoregressive models, which generate like a single video token at a time, or like chunks of the video tokens, which maybe within themselves would have bidirectional attention, but it totally depends on the architecture. Yeah, those are, but like, I described a thing I don't like about paradigms, right? I guess I framed it in terms of performance. I did say like clip features aren't good for generation. That's a shortcoming. Mask VQGAN features aren't good for understanding. That's a shortcoming. For now, though, we get around that shortcoming by just using the encoder that we need to use for the task we need to support. And even for these models, which can generate image and text both, in the academic space, at least, we don't really have satisfying benchmarks for that. You'll see that they'll do understanding benchmarks for the understanding side. Do we not have tables in this paper? Surely we have tables. Yeah. We'll do understanding benchmarks for the understanding side, and then generative benchmarks for the generation side. This is GenEval. This is WISE. Wait, WISE is more understanding. No, it's like the understanding of your T2I. Okay. Yeah. So they're still separate though. It's not like we're examining the quality of a sequence that actually has interleaved text and image, right? We're examining the quality of the text and then separately the quality of the image. So maybe as these get more mature, there will be more of a need for single vision encoder, but at the same time, when your LLM is 70 billion parameters or more, and these image encoders are each like 400 million parameters, why do I just need one? Why not just use two? And so there's not necessarily like a big need to unify them. Some of us feel compelled to do so conceptually, but practically, this is just not that expensive. And so do I really need to do that? Yeah, it is a good question, though. Someone kind of mentioned this earlier. What exactly is the cutoff for this series? Because if you're trying to bring it all the way to the present day, there's like a million directions. And which of them will survive the test of time? Who knows? I don't know. But something I might do is like maybe I skip things like blip and I just stick to the thing that I feel has been like a little stickier and a little more influential. Maybe that's a good way to do things. And then where do I stop? Like how do I take us into the present day? Do you think the direction of studying how to bridge embedding and generative models? This seems like a very interesting representational line question. I mean, that's been a lot of what I've tried to do in my work, right? Like if you look at my most recent paper, right? Or what's it going to say is my most recent? Okay, not technically my most recent. My most recent first author, right? That's what I'm trying to do. I have this system and I want to be able to I want to take the same embedding and use it to classify and also to reconstruct. And if I can use it to classify, if I can use it to reconstruct, well, reconstruction means I can do the generation, right? Problem I have is I obviously don't beat the SDVAE, right? My FID is higher. My SFID technically is a little bit lower, but then my inception score is worse. Precision recall, worse. And beyond that, this is like super toyish, right? We're talking about just class condition ImageNet, not even training it very well, right? This is a setting from their real paper, by the way, the DIT paper, but it's like one of the settings they use in the ablations. And the reason I don't train this more is just because it doesn't really work super well, so there's no point. Like this is the proof of concept basically, but does this work? No. There's other papers that try to make it work. It's just really hard. So personally, I do think it's a good question. I think it's a hard question. I've studied in other work too, like we had a couple of papers. The conference accepted one was this, but it's basically like we can go into the diffusion model and grab the feature from the diffusion model and classify it. So obviously the diffusion model generates. We can also take its model and we can also take its feature and we can like train a linear probe on it. And if we train the linear probe, we would get like 64.9% accuracy. Whereas if we train something fancier on it, we could get maybe up to like 77%. Which is approaching things that were SOTAs, but then you have like this paper Mage, which combines like a mask VQ-GAN with some like denoising objective, and they get something even higher, right? So maybe this is even better when you talk about like that unified paradigm. I'm trying to remember what their generative was like. I think this is a pretty cool paper though. If you're talking about unifying representation learning and image synthesis, it's even in the title. And they do a pretty decent job. Can't remember the exact numbers, but the issue is you're just like, it was a little bit worse than ibot at the time, and Dino v2, Dino v3 sort of subsume ibot and become even better than ibot. And then Mage, obviously, class unconditional okay, no one really cares about class unconditional first off. And then when you add conditions, there's just not a way to make it work super well. So it ends up being not so popular. And also from talking to the authors of this, I know that while our diffusion classifier could do segmentation and depth pretty well, segmentation and detection pretty well, these features, for whatever reason, can't. This model does not yield good, dense features, which would also mean you can't really plug it into a VLM. Not to mention the fact that the features aren't text aligned, right? But like the generations are pretty good, especially for unconditional. This is like super good. These are really good unconditional images. But again, unconditional is sort of a toy task. And so this is always relegated to the status of like decent, but not the best, and works on toy problems and toy data. Yeah. I think it's a good area, but it's a tricky area. What I found to be strange in this direction is that when word embedding is like a Word2Vec started working and LLMs like GPT came out, they didn't use pre-trained. Yeah, I've always thought that's a little weird too, that they didn't use any of the pre-trained or like predefined embeddings. But the reason is you get a better embedding that the model likes better by training from scratch. And do I think this could be a sign that current architecture can't bridge embedding and generation? If anything, I think what you're saying about the Word2Vec thing is a sign that current architecture should be able to bridge embedding and generation. I feel like the ideal architecture, why would you pre-train the vision model? And then why wouldn't it generate and understand? Because your LLM backbone should be able to give you both image and text tokens, and honestly, audio tokens and whatever other modalities you think matter as well. So if anything, I think that Word2Vec example points to the idea that the optimal system is obviously trained end-to-end on all of it to do whatever you want it to. Some of the barriers to this are the compute itself. Like, image models have different compute demands than text models, which means doing your pre-training interleaved would kill a lot of the massive efficiency gains that we've seen over the years that have allowed us to do any of the things that matter, basically. Build the models as big as they are, train them as much as we can, as fast as we can. Introduce images to that, you throw it all off. You don't know what your scaling law is anymore. So for now, we're just building Franken models. And maybe at some point we'll build models that feel a bit more principled. Okay, let's close some of these papers that I just pulled up for the purpose of illustration. This was not one of them, but do I cover SWAV? SWAV and Deep Cluster were when, no, Dino would be the better paper, I think, if I'm going to cover some image-focused contrastive learning type stuff. I think the paper has to be Dino. It would never be SWAV. And it's not like I don't think I cover BLIP2 and visual instruction tuning. So I think it's just visual instruction tuning, right? Video's so tricky though. I don't know. If anyone in the chat has good ideas for video models, let me know. Oh, Hassan, am I changing the streaming schedule? That's a great question. I am. I'll address that for anyone that's here. I talked about it yesterday when I went live. I have one other thing I have to do on Saturdays, and it does take priority over the stream, and it keeps trying to move itself on top of the stream. I thought when I made the stream schedule, I knew the schedule for that thing, and I designed the stream schedule with that in mind, but it kept wanting to move itself. And also it capped my stream. It meant my stream was only ever going to be able to be 2 hours. Hard stop, 2 hours. And also I kind of like being able to be early for that other thing, because then I can take the kids out extra early and it's just easy, and my wife gets even more time to just do whatever she wants to do here, like read or make book talk videos or whatever. So it just makes a little more sense for me to do the weekly streams on Sunday when I don't have a firm back end and when there's nothing I have to worry about moving on top of the stream, as opposed to when I was trying to get it done on Saturday before my other commitment. And also, like, making myself wake up, and then if, like, the numbers weren't good, I knew I had the back end, like, the stress would just kind of compound. So long story short, I am moving the streams to Sundays, and for now the plan is 9 a.m. If I get enough people that I really feel like they'd be there at 8 a.m. if I was there at 8 a.m., then sure, I'd go live at 8 a.m. But all of my tests streaming so far suggest I don't even have any correlation between one time and another time. So what's even really the point? That's where I'm at right now. Okay, let's close some tabs still. Let's try to keep only stuff open that I feel like it actually covers. Siglep 2, not something I'm going to cover. Cool paper, though. MAE. See, this was like a question. Do we cover stuff that I feel like is dead? That's RCNN. That's MAE. That's... See, GANs are alive in a way, so I think I cover GANs. UNet is alive, or is it kind of dead? See, that's why it's like... what to cover. And then, goodness. Okay, so contrastive learning presents a problem, which is, I could just skip to Dino, but that sucks because it was these papers, SimClear, Perl, and Moco, that showed that you could really do it at all. Or is it those papers? It was kind of this one that, like, nobody even knows, that has, like, no citations. All of them cite it, but then no one else does, because this was the state of the art for, like, 2 minutes, basically. No, this is the wrong table. This was the state of the art for like 2 seconds on both classification, and I don't know if it was state of the art for generation because I don't know it well enough. But it was a very good generative model for its time. But it was immediately beaten by the contrastive stuff and just fell totally out of people's awareness. So I don't know what to do with this one. I mean, I don't think I covered this one, obviously. But yeah, I don't know what to do with Perl versus SimClear versus Moco, especially in light of the fact that I am going to cover Clip, and it sounds like I'm probably going to cover Dino. So it's like, what's the role of covering SimClear at that point? Like, SimClear kind of helps you understand Clip, and Clip shows that the key to text is the amount of data. But it doesn't necessarily, it's not the thing that shows how contrastive learning works, right? That's these papers. So I'm kind of stuck thinking. But that's, with contrastive learning, I feel like my problem is an embarrassment of riches. There's so many papers that are all great. Maybe they introduce similar ideas concurrently. Which ones are the right ones to pick? With video, I feel like I have the opposite problem, where it's like kind of like no paper comes to mind. Because vision, it feels like, was often consuming ideas from language at this time, but there was a fair bit of exchange. Like the massive contrastive idea, for example, I think originated in image. It's not like we just stole that from text. Whereas video, I don't even know if it really originated ideas. It was just sort of like, let's take whatever's working great for images, do the necessary little tweak for video, and then it barely works. I should consider creating the Discord server now. That's a good point. What goes into creating a Discord server? I know we get some decent messaging stuff on the free tier. Not that I'm that cheap. Like, I could pay for some Nitro. The thing I'm worried... Okay, 2 things I'm worried about with the Discord server. One thing I'm worried about with the Discord server is that no one would be there. My opposite problem is that people would be there and they would troll. And, like, I'd struggle to keep it moderated. Does Discord have auto mod? Like, what protections do I have from random people coming in and just, like, saying terrible, terrible things that I then have to spend my free time pruning? Or is it the kind of thing where, like, I make one and I just wait for that to happen, and when it happens, I maybe shut it down because I just don't feel like dealing with it? But we just pray that our unwalled garden stays undefiled until then? I don't know. But in terms of I should consider creating it now, I'm definitely considering it. It's just a matter of sitting down and making sure I'm comfortable with the risks. And also, in the moment that I create a server, I do feel like I kind of have more properly a community. And like right now, who knows? People could be saying horrible stuff in the chat right now, and none of us would see it because I have the basic YouTube auto mod turned on. I think the auto mod is supposed to tell me when it actually does something. But like, I don't know. I've already had to. The Automod didn't catch something the other day, and I had to like ban someone that came in and said something crazy. And it feels like we get a bit of that on the Discord. So I don't know. Maybe there could be chatters that I trust enough to make them mods, and then I don't have to think about it too much. But then that's scary too. Then I'm saying I trust this person, and then what if they do something, and then that kind of comes back on me, right? When does the CV series start? That's a great question, Hassan. It starts as soon as I feel like I know the start point. I think I've brainstormed quite a few here. You know, we could go all the way back to this paper, which is even before backprop, or we could start at backprop, or we could start with like a Linnet recap, or we could start with whatever Schmidhuber says is his thing, which he does point to those neocognition papers. He also points to, where is that? We had Schmidhuber's complaining block open. Here it is. Like there's those. There's also, I think this is his paper, right? No, it's just another one that's also not his, but he says this before. Like we could start with, yeah, first modern back propagation train two-dimensional CNN. We could start with this one, which was, in fairness, like concurrent to Linnet. Or we could just start with Linnet because it's what people know. Or we could start with whatever I feel like the most important touchstone for big data is, which would be, we had it open, this one. Or maybe it's a different one. Maybe I need to think about it more. Or you could start with ImageNet, or you could start with AlexNet, or no, we're not starting any later than AlexNet. AlexNet is, I'm positive, the latest I'd possibly start. So the question is just, is it AlexNet, or is it any of these 10 papers sooner? CNN 1A Plus looks like a nice option. Sure, but we're kind of just indulging Schmidhuber's rambling. I think if we start specifically with that one, why can I not find it? Because like he's complaining this predated Linnet. It's actually pretty dang concurrent. Like technically this appeared 88. I don't even know if this was LeCun's first one. This may have been Linnet 2. And it was 89. Like they're like let's go on the Wikipedia again. That gives me all the Linnet titles. Like what's the, okay, so let's see. He joined blah blah blah. Okay. Hand designed kernels. Okay, so this paper, NeurIPS 1988, right? But this other paper does supposedly apply backprop to the 2D CNN. And it is, like, it's just really hard. I don't know the publication timelines. Certainly this was published sooner, but is it actually earlier? I don't know. And if I look at this paper, we can look at it right now. We can look at them side by side. Like, is this paper going to be a better thing to present on the channel than this paper? Which I actually have the PDF because Schmidhuber did us a solid, and he's got the PDF right there. Oh, geez, English translation? Is this paper even in English? Or is it in Japanese? I mean, because I can't read a paper if it's just in Japanese. I think it is. So, you know, I have a hypothesis about how LeCun would have missed this paper if he did indeed miss it, which is he doesn't speak Japanese, and it was published in a physics journal, right? Whereas LeCun's is published at NeurIPS. Yeah, backpropagation applied to handwritten zip code recognition. See, so I think it would probably be the paper that I can actually find a copy of in English. I would mention this one for sure, that some people are like, actually, you can see backpropagation in this paper with the CNN. I would mention it for sure. Yeah, maybe that makes this paper a good time to start. But then it's like backpropagation applied to handwritten zip code recognition. It's like, Matt, why didn't you just like talk about backprop? Maybe that means I do backprop in the same video at the start. And so it's like, maybe we have a whole video that's the before times video that covers backprop, that mentions Schmidhuber's complaints, and that covers like the Linnet series. And then the next video would time skip and it would be data. And so maybe it's like, maybe the fact I don't feel like I can just decide on a paper actually is fine. And some of these earlier videos, heck, maybe that's just what I do every time I can't pick a paper, right? Maybe not being able to pick between PRL, MoCo, and SimClear simply means I do a video called The Dawn of Contrastive Learning or whatever. Okay, it's some title that's not just terrible, and I just cover all three. Maybe that's a better way to do it. So maybe it's a series where like it's not sorted by paper, because sometimes papers are concurrent. So instead it's sorted by subject. And that means that in my big ResNet video, I can actually use VGG, and I can use like Inception, and I can use DenseNet, and it'll give more context. And maybe I spend most of the time in the ResNet paper in that particular video because it's just my favorite. But like that means I'm not asking this like either or, and I can just present more completely the information. I don't know. Yep, sort of. Yeah, definitely. So Hassan, even if every video is a paper, it would still be sorted by subject, right? Like it would be like, this is the diffusion paper you should know, right? And the subject's diffusion. Um, but there would also be like, I'm not doing Dhariwal et al. It's not Dhariwal at all. It's Dhariwal and whoever the second author was. I can't remember right now. We're not doing the Dhariwal paper and the Peebles paper in the same video. I want those to be 2 videos. So some things will come up again. It'll basically be like sometimes it's a topic that became big all at once, and then sometimes it's a paper that I think was an important touchstone. I do think okay, my only problem with that idea is a very fun way to make the series really pop, I think, would be to call it something like the only 10 papers you need to catch up to modern computer vision or something, right? Like, obviously that's a clickbaity idea, and I don't even think it's totally true, but something to convey like, there are so many papers I like, but I pruned this down to like the bare essentials of like the best. So a possibility could be to start at AlexNet and go forwards and backwards as you please. Okay, so that's a thought. I definitely could do the videos out of order, especially because it's not like my core fan base is just a few dozen people maybe, and then there's like a few hundred subs, but like it's like not like they're fans. So would it bother people that the videos aren't coming out in order? Maybe not. And so maybe I do just start on video things I know I want to cover, and I sort of fill in blanks as I go. The only risk in that is I cannot make the only 10 papers you need to know unless I've picked those beforehand. I know that this is a series that a lot of people have asked for, though. Like I know you, Hassan, are interested. I know Ift is interested. And a few other people have mentioned it. So I'm trying to get it together soon. I also did just start a new job a few weeks ago, so that's been pretty busy. So that's like my side excuse for why that hasn't been more fleshed out. This brainstorm is very helpful, though. I think actually getting these papers in front of me, like instead of just thinking about it or like making notes, actually just having all the papers open and like answering questions about it is helping my thought sort of like solidify into something real. And it's going to make it easier soon to make the big decisions I have to make about the series. What's the one thing you wish you would have done during your bachelor's that would help in your AI research / PhD years? Like maybe a more math / focus on basics more? See, this is always tricky for me because I do tell people like, oh man, I wish I had taken more maths courses or maybe even majored in mathematics. But like I got where I am today, and like every step, it's like a butterfly effect problem where I got the opportunities I had because of my CS background. So I wish my background was different, but I don't know if I would have had the same opportunities if my background was different. I don't know if I would have talked to the right people at the right times, and that was incredibly consequential for me getting into the PhD program that I did, and getting into the lab that I did, and getting the support I did, and the internships and whatever. Like all of it combined to work together. So it's hard. Like if you already know what you want to do, which I didn't when I was doing it, I didn't know. If you already know, then yeah, maybe the thing that makes sense is like math and just know that you need to talk to the CS faculty. Right? But if I had done math, I wouldn't have known like I didn't know what I didn't know. So if I had a time machine, sure, I might go back and tell myself, "Hey, you're going to want to be a deep learning researcher. You should major in math. Maybe double major in CS if it's an option or minor, and you're going to want to talk to CS profs in these areas about their research and see how you can get involved that way." There's no way I would have known that at the time, though. I guess I could tell you that I think that that could work for you, but you're going to have to be careful because um, it's obviously just you're typically going to have more chances to interact with the faculty in your major, and that's typically where most people would look for their research opportunities. And so you're just going to have to already know, like, hey, I'm looking for research mentors that are going to be on the CS side. And you're going to have to try to win them over with your math background and prove that you have enough coding skills to keep up. Which I guess the coding skills thing doesn't matter as much these days, but hopefully you get what I mean. Elias Sutskever told John Carmack to read these 27 papers that provide the foundation to AI. Oh, that's actually not something I'm familiar with. Let me look it up. Ilya Sutsky for 27 papers. The 27. Oh, goodness. Do I want to go into Less Wrong right now on stream? I'm not trying to signal boost Less Wrong right now. Okay. Know that things I put on the stream are by no means an endorsement, okay? So I found it here quickly. We're just gonna roll with it. Some of these are like tutorials. Like I see the CS231N Conv Neural Networks course. That's just a tutorial, right? Or is this even kind of like a blog style? Yeah, no, it's just the course. There's transformers. There's dilated convolution. This is ResNet, yeah. There's ResNet. Is this the title of AlexNet? Yeah. There's blogs, few blogs. Yeah, it's a mix of blogs and papers and then a course thrown at the end there for good measure. That's interesting. Mine obviously would be vision focused, right? What's this? Can we tell what the starting point is here? RNNs. I guess AlexNet might be the earliest thing on this page, right? What's this? Yeah, way older than well, way newer. Sorry, way newer than AlexNet. That's gonna be, I think everything I'm seeing. Wait, really? This one? Huh. I'm surprised he points to this paper. Maybe I should think about that a little more. Yeah, this is all. Oh wait, when was this paper? After AlexNet 2. Okay. Scaling laws. That was like 2018, no? 2020. Okay, I was off by 2 years. Dang. Yeah, I think. So this is like AlexNet, and then we jump like 3 years. How much do I want to jump 3 years? Because like I kind of want. I like that GAN's paper. I like that CNN's DPM's paper. Those would obviously be in between. Obviously, those are more vision focused. And this is 90% of what matters today. When did he say that? I wonder. 2024? Because like this is missing RL, no? If you're talking about just what matters today in deep learning. So this wouldn't have RL, and you would obviously want to know GRPO if you're going to do anything right now. If we thought more, we could come up with more things that are probably missing. And then there's probably things here that you just don't need. 2 years later than the list was compiled or whatever. Interesting. I'm waiting for you to come up with the clickbaity title. Yes, I feel like the clickbaity title, once I make one video, it kind of boxes me in. Like, maybe AlexNet doesn't box me in because I'm doing that no matter what. But there are other, like if I make AlexNet and then I do 3 papers in one video to do contrastive, I'm suddenly boxed in. It can't be 10 papers. I wouldn't be doing 3 contrastive learning if my budget is 10 papers. Yeah. Hi, Matt. I got to know your channel when I'm learning more about applying for PhD. Really love your content. Thanks. How do I pronounce that? Dongtran? Tranin? I feel like I'm looking at like last name, first name, middle name or something, but I'm not sure where to start with each. Feel free to give me pronunciation guide for names, by the way, because I like to pronounce names correctly, and often the first time I read a name, especially when it's all one word, like a YouTube name, I say it wrong. Bahavia, I I want to go for AI research for long-term. Thanks. Also, like even in math, what to do, like solve problems or like do theory, understand the connection between math and ML algs. Yeah, I think like people will point to like functional analysis, I think is something you should know. And obviously you should know all of your actual deep learning fundamentals, right? Like you need to be very comfortable with linear algebra and multivariable calculus. Those obviously aren't very complicated. They're hardly even math, right? It's like just fancy arithmetic kind of. Differential equations are nice for different things that you're doing. It's weird because I have a certain view of theory, which I'm not going to really dig into right now, but I feel like if you have solid math background, there is very often somewhere to figure out to apply it. So I'd almost say like, if you're talking about your undergrad, you should already be trying to be involved in CS research before the times that you'd be picking these senior year electives. And so you would get that general background going up to hopefully starting that research end of sophomore, start of junior year. And then by the time you're really not sure about courses, hopefully your CS research can inform some of those decisions and selections, and you don't need to lean on me for that, if that makes sense. Obviously, if your school has some dedicated like applied math, or maybe even some like math with deep learning focus, that's the thing for you, right? But not all programs necessarily have that, so it just depends. We also need a research guide from you, like how to do research. Yeah, I think the tricky thing is that the PhD, Hassan, is 5 years of learning how to do research, right? So distilling that into a guide is something I want to do. It's also something that's very hard to do without it becoming incredibly superficial to the point that it's just not helpful. So that it's something that churns in my mind a lot. It's a type of video that I feel like I've already made. No, have I? I've really made nothing that, like, I mention it sometimes, offhand, little things, right? But I've not made anything that focuses on it properly. And that's really a matter of like wanting to do it well or not doing it at all. And so far, nothing that comes into my head feels like doing it well. I don't even know if it's real or not. He didn't quote it directly. I don't know the source. Oh, really? Like that person just like kind of like Sutskever never said it. Someone just said he said it, and maybe it's like made up. That's pretty funny. Um, I have a doubt lately. Most U.S. master's degrees are on 60 to 100K USD, which is too expensive for me. Yeah, I mean, too expensive for a lot of people. Olina bin? Olin? Abin? See, I don't know where the names divide, which makes it harder to pronounce. PhD requires a lot more preparations, basically out of my reach. What should I do? Um, that's a great question. So a very unhelpful thing I could say is sometimes in a master's degree, you actually can get support, like if you're able to find a job as an RI or as a TA, but that's not helpful because you can't guarantee that when at the moment you're getting admitted and committing to pay. And also funding is pretty bad lately, so that's less true. It sounds like based on what you're saying, there's sort of a forcing function here, unfortunately, which is you can't afford the master's and you can't do the PhD, so go into industry with your bachelor's, right? That would be the thing you're just kind of forced to do. And I would say that the important thing is to try to the extent that you can, migrate yourself closer and closer and closer to the research, right? Uh, yeah, like research teams need engineering support. There actually even are roles that I know of where engineers get their names on the ML research papers, right? And so it'd be a matter of just trying to get closer and closer. And then sometimes when you get as close to the research as you could possibly be at the company you're in, that's the time to look for the hop to a place where you know you'd be able to get even closer with your bachelor's and with your experience as a research engineer, right? You'd always be looking for research engineer titles, people that are willing to accept candidates with bachelor's. And basically the big inflection point would be the first time in your career that you get close enough to where your name is on the paper. And that'd be a pretty big deal. Or the first time you get close enough to where the product experience that you can talk about on the resume is actually on the order of, building and training the model. And so I think it is just sort of like a ladder climbing thing. It's like the way you plan your career and the way you handle it day to day should be all about being able to get just a little bit closer to those things you want to do. Obviously, it's not as optimal as doing the masters and giving that signal to send them immediately that you know these things. I would say if you're saying this to me and you're not done with your bachelor's yet, the answer is to do more research, right? And like build up that resume more. But it sounds like we're talking about a moment where that's not really possible. Maybe you already applied and you're looking at these masters and they're just too expensive, right? So yeah, I would say in that gap, just get as close to the research as you can. Obviously, if you can find a role that lets you publish, great. This could be a gap and you could reapply for the PhD and get into it. I've seen people do that. I've seen people take the bachelor's and then do actual research in the industry, get papers, and then they can come back. And sometimes the people they work with in the industry are even themselves well-connected PhDs that can help them connect back to different programs. But then we're talking about being in super elite places in industry, and that is not practical general advice, right? Hopefully that helps a tiny bit. Do you plan to have some kind of videos on how to do AI research that covers your own research pipeline from how you come up with ideas to plan the experiments to do writing? Yes, I do. Like I said to Hassan, and maybe you asked your question like before, so you already heard kind of the answer, but it's just a matter of putting it together in a way that I feel like it's actually helpful. Because the last thing I want to do is spend 10 minutes recording a bunch of platitudes that don't help anybody and just get me like a couple hundred views and like whatever. Like, I don't want to waste your time. It would be a good video if I did it well. I need to do it well. And so it takes more thinking. Always thinking though. And my name is pronounced Zung Chan. If you happen to have a Vietnamese friend, they will probably know. I do. I can't ask them right this minute, but I can ask later. Tran, is that decent? But Zung, I'm not sure if it's like Zung or Zung or Zung or Zung. You can also type phonetically if you want to. Um, Time to use knowledge distillation. I'll train my brain smaller model to learn from your experience. 5 years of PhD. There we go. Knowledge distillation. I like that paper. I'm actually glad you mentioned that. That had like fallen out of my brain. But when we're talking about like my history of computer vision, this paper has to be there. I mean, this is like everywhere, right? Like we're distilling big language models into small language models into VLMs. We're distilling diffusion models into like turbo diffusion models. We're distilling what's another one? We're doing all kinds of crazy distillation all the time in the field. We're self-distilling. We're having a dyno that's trained with self-distillation at the 7B scale, and then we're proactively distilling the 7B model to the 1B scale, to the 700 million scale, the 300, the 70, I think they train an 18 million model, all with distillation, right? So this is a huge idea still. I can't believe I didn't say that in the stream already. This has got to be in what I cover. It just has to. Okay. Glad that word came up in the chat. I don't know if I would have forgotten it, right? But like this is why it's so important to like really map it out and to think about it after I've mapped it out before I do a video, because otherwise I'll box myself in with the title, or like I'll create some weird hole where like I vaguely reference the idea of the paper without mentioning the fact I've never covered it or plan to cover it, and that just creates like a suboptimal version of the series. So it's good to get that up there. But Zongtran. Okay. I hope Zung is okay. If it's closer to like an U sound, or like if any of the other sounds are super wrong, just let me know. But Zongtran. Okay, Zung. I think Zung is fine, right? We are trying to do KD here. Okay, I think I'm caught up to date with chats. Geez, look at all these tabs. See, like I'm not doing this many videos in my History of CV series, but I think these are all individually different papers that we have open. All of which are amazing papers, right? Like these would all be, okay. I like this paper a lot, but it's not like one of my amazing historic papers. But the rest of these are just incredible papers, and I'm obviously not going to be able to cover, do I have Perl open twice? I do. I'm obviously not going to be able to cover all of them. So it's a matter of like, how much do you cover, right? I just realized I was going through these and I got sidetracked, and how many did I make it through? We made it through 15. Did we get 16? Oh, see, this is where I said it's like hard to figure out what to do before 2008. This is a candidate. I'd have to look at it. Yep, that's a candidate, I suppose. What's the deal with this paper? Because it's not in the Linnet series. I'm not really familiar with this at all. I know that it's a covenant for classification. Maybe that's an important bridge paper, but I don't know if bridge papers are getting like proper history of computer vision style videos in the scope of the series that I'm trying to do. For scalable, okay, unsupervised learning of hierarchical representations, like does something like this deserve proper, like, because this sort of thing predates a lot of the ideas we're going to come back to later. See, and this is where we're talking about convnets with learnable filters, right? And so maybe stuff like this even makes it to where I can prune some of my later papers that I wanted to talk about filters, because you can see, the different scale. Like, okay, I'll zoom in so you can see. We can see how when we're recognizing cars, we have earlier layers get car primitives, and then later layers get like actual like car recognition, right? But the layers kind of build on each other, going from like the super low level to the more high level. 22, what's that one? A high throughput screening approach to discovering good forms of biologically inspired visual representation. See, like this is probably not one that I cover, right? But he felt the need to cite it for CNN. For those that weren't here earlier, this is AlexNet, the paper, and there's a bunch of papers that he cites when he mentions the idea of CNN. And I was just opening all of them to kind of see where he felt like the inspiration came from, or what he felt like the functioning ones were, because that seems like a pretty decent proxy. I don't think that I don't know. I'm hesitant to use popularity as the only benchmark, but I don't think that the 500 citation ConvNet paper from 2010, like these probably don't belong in the series, right? And yeah, probably not. But then I see stuff like this, and I'm like, I see stuff like this, and I see stuff like this, and it makes me want to be very, very, very careful. Because one high value thing I think I could do is make people a little bit more aware of what was happening before AlexNet that has a lot of influence on things happening at and beyond AlexNet. So I want to be very careful not in my ignorance to sort of dismiss these things, right? But then you see what these are doing at the time, right? Like support vector machines. And then I'm like, what's even the first support vector machine paper? And can we even talk about deep learning pre like 2015 without effectively handling the role of support vector networks and support vector machines? And I'm not sure. I need to think about it more. What project/topic would you recommend for a CV course team project that would look solid on a resume? That's a good question, Arena. I think that I still feel this is advice I given in the past. Let's see how true it is now. Is this a good time? Yes, this is the perfect time to look at it. Okay. CVPR 2026 workshops. This is my advice. Okay. So let's open up. Okay. Let's just send it. Good luck to us, right? Okay. Let's open all these workshop websites and hope that some of them are alive and current. Call for papers. Is there a challenge? No. Okay. Is there a challenge? Okay, I see they have a new benchmark. But do they have a challenge on the benchmark? Oh, this is a challenge. Perfect. This is my recommendation, Arena. This. Not literally this one, but like this is the perfect time of year for it, and you're probably asking, I'd assume, because you have a course. And so this is like happening soon. Go to CVPR 2026 workshops. Open a bunch of them that sound interesting. See if they have a challenge. And even if you don't literally, if you're looking for it to be good on the resume, participate and do well in the challenge. If you just want a decent project, just like pretend you're participating in the challenge, right? But these offer cleanly scoped problems that are considered cutting edge to at least these 5 people, right? And you can look at their own resumes to consider how much you might respect the opinions of these people. But that gives you a lot of signal that you cannot replace with a simple like ChatGPT or Gemini query or with the Google search, right? This is giving you opinion signal. These people are putting their names on this benchmark in the year of our Lord 2026, right? So that's why this is my advice, because instead of me being hand wavy and just throwing a bunch of half-baked ideas at you, these researchers are saying like, does this have a challenge? Yep. Well, this was a challenge last year, I guess, but they're saying this is the cutting edge. This one's over, but this can be decent too. Like 2025 challenges are still not so bad to do. Some of these, it's like we're still just incrementally making progress on them, right? Although maybe you can see like, is there an image matching challenge 2026? They may just not have updated the website. Yeah, I don't think they updated the website. It does say they'll once again feature an open challenge, so it looks like they'll have a challenge later. We're getting kind of close though for them not to have organized it yet. So you could always like reach out to the youngest seeming organizer. That's the person that's most likely in charge of most of the day-to-day. If I had to guess, you could just reach out to all of them if you feel like you have the time. Although you might just start by looking at whoever's more junior and then slowly moving to whoever's more senior if you don't get responses. If that's the one that you think is just so interesting and you don't want to do the 2025 version. But yeah, you would just go through all of these and yeah, you can Control F challenge or you can Control F benchmark, right? So we just got a couple. Cool. This one has multiple challenges or just one this year. No, multiple challenges too, right? Building 3D challenge and S23DR challenge. So challenges, lots of these. I'd say about half of these will tend to have challenges, and they'll tend to be new, and they'll tend to actually show you what's considered to be on the cutting edge of computer vision right now. I took a nap and you're still alive? Yeah, Banana, maybe I should have taken a nap. I won't be alive for too much longer. My wife decided to go out shopping to pick up a couple things, and she took the kids. But as soon as they're home, I want to hang out with her and the kids. So let me even see. Is she still at the store, or is she? Okay, it's ambiguous. She might be on her way home. So I might not be live for much longer. Because Sundays are a nice day to hang out with them. Okay. Yeah, I hope that gives you a good answer to your question, Arena. Okay, sweet. This is great advice about doing challenges. We'll keep this in mind for my final year of my final project for my bachelor's. Yeah, son. I think it could even, if you're willing to be really diligent, you could take a look kind of at all the workshops and what they're saying is on the edge. And maybe if you wanted to, especially if you're thinking about like a bachelor's thesis, for example, you could try to synthesize different ideas and challenges. Or maybe because some of these workshops are going to be really related. And so maybe by looking at what all these different 3D things are saying, you can kind of come up with the synthesized, well, these are the key challenges confronting 3D at the edge. And this is a thing I propose that addresses many of them at once, right? Because especially, I mean, the whole concept of foundation model, right, is that, here, do we have lava open somewhere? I think we do, so I don't want to go to Google. Like, the whole concept of foundation model is, okay, whatever. Visual instruction tuning, here we go. Now to start the same sentence for the 5th time. The whole concept of foundation model is that I can handle many, many, many tasks with many different nuances with a single model, right? And so in a similar way, many of these challenges you could potentially tackle with a single unified approach. And so that might be something to think about if you're trying to dream bigger. Although I will say, just winning one of these challenges, I feel some people might look at it as worse than a first author paper at the main conference. Others would look at it as better. It just kind of depends on your person and the level of attention they're willing to pay to what happened. I think in industry especially, it would tend to signal on the stronger side because it shows that you can really build a system that works as opposed to just like being able to understand enough to write the paper. You know, you actually like beat the other approaches, which is cool. And it sends a really strong localized signal, which I think is something not to underrate. Like if those people are hosting the challenge and that's the research that they care about and you have the strongest approach and you're like, hey, I'm actually on the market, I'm looking for PhDs next year, maybe they're hiring and they'll choose to hire you, right? Because you're giving very good signal that like you're interested in their research and you're already like on the bleeding edge of it. Okay. I think I'm starting to feel my brain's a little tired. Um, I'm definitely in the mood to sort of wind down the stream. I think I'll at least lean back in the chair a little bit. I kind of want to decide before I close the stream, though, for this computer vision history series. Do we do the cover everything I feel like covering, and so some videos are like all these different papers? Or do we keep it really punchy and it's like these 10 papers? And then when I'm done, I could even release the supercut video, which is the only 10 papers you need to understand computer vision. And that would be like a video. And it would just like squeeze them all together and be one long video. See, that sounds appealing. But on the other hand, I could do it without these 10 papers and I could still do the supercut. It would just have a different title. And at my size and with the way my channel performs, my issues with performance are often past the click. Like sometimes I get decent watch time. I've never had exceptional watch time. At the same time, you could say that's because of a title content mismatch. But if anything, that just means I need to clickbait less, right? Not more. So I don't know. There's something powerful to me, the idea of trying to distill everything into 10 papers. But then there's something else satisfying about just being thorough, right? Because part of the point of my channel and part of the perspective I think I bring is like I'm just a guy that does research. I'm not like an entertainer. I'm not an educator. Um, so it is just like my opinion and my taste. And like these 10 papers, that's like an entertainer angle. It also kind of makes it sound more approachable for you, maybe. It's like, oh, only 10 papers? I can do that. Whereas when I'm like, hey, here's 30 papers. But at the same time, in the moment that you finish my videos, you've gotten those papers covered. And now instead of covering 10, you know 30. So what if the unique thing I bring to the table is that I do 30 papers? Not in 30 videos, but like, you know, some videos I am bringing up multiple papers or comparing, or what if I do 10 papers, but I'm allowed to reference the others and do quick little spotlights. It's like maybe for contrastive, I pick SimClear because it might be, you know, what is the most famous actually? Scholar. Um, SimClear. Let's rank these papers real quick. Oh my God. Of course they didn't call it SimClear. They called it, what the heck did they call SimClear? This, okay, there we go. So 30K, right? 30K for SimClear. How many for Moco? 20K. Is this the actual Moco V1? See, the problem is Moco V2 comes out like right after. Okay, but only 4K. Okay, so I think we're seeing it's obviously SimClear because like we can't even look up Pearl by the accurate. Well, neither could we look up SimClear. Yeah, 2K. Okay, so yeah, SimClear is the famous one for sure. Why did I look up SimClear again? I just found out I couldn't. So it's like, but do I have to do the one that's famous just because it's famous? I don't. So I could say I like Moco better. I could say I like Pearl better. And the video could be a Moco on Pearl. I mean, Moco and Pearl were both a little bit earlier than SimClear. By the way, this is a great example. Never worry too much about getting scooped, right? Because like this paper went online. We covered this earlier in the stream, but I'll just point it out again. Why did I do that? This paper went online, I think February 2020 for the first time, which was 2 months after Pearl, which was 1 month after Moco. But which paper has the most sites? Chen and Hinton. So maybe getting scooped is okay sometimes. Well, the 10 papers can be the basics and the rest of the papers can be other supplementary videos. Yeah, it's possible. Although what I'm saying is I don't think I want to make more than 10 videos. So maybe every video is centered on a paper and that helps keep things organized and then the others are supplement. Maybe diffusion is Dhariwal and I just bring up DIT for 2 minutes in it to say like, hey, UNet is one way. You could also do the transformer. The key thing going on here is the reverse denoising process itself and the learning of it, which really hasn't changed a ton, even in the last 6 years. Do I even need to do flow matching? I don't think I do. Maybe I should. Maybe flow matching is the thing I mentioned in the Dhariwal video. And then I kind of snipe diffusion like all in one go. One paper. And I could do GANs real quick in that one because sometimes people use GANs as diffusion. And I also mentioned that diffusion was replacing the GANs. You know, diffusion beats GANs. What's a GAN? Here's a GAN. So it's diffusion beats GANs. That's the paper. But these other papers that are related get to make an appearance, right? Well, now people do some flow matching. Well, it beat GANs. This is a GAN. Well, it proposes a UNet, but this is the DIT. Heck, maybe that's when I do UNet. Here's the architecture that this paper is using. You know, so maybe anytime there's a video that I'd be doing because it's a prereq for like one other thing, maybe that's a sign that the video is actually about the thing that I'm saying it's a prereq for, and we just cover the prereqs in the same video. That's maybe a way to think about it. You know, because if I do it that way, then we get like this. Like, okay, so let's think about 10. If our budget is 10, maybe 10 is even high. What if this was like 5 videos? Like, let's see. Like, how bad is it if we try to conceptualize it as 5? Okay, so we need to do diffusion, but we just talked about how we do diffusion. Beats GANs, which also covers GANs. And we'd also include DIT, and we could mention flow, maybe. And like that could have diffusion pretty good. And we can also have one paper to mention the conditions, like one of the early ones, like some paper to be like, oh, by the way, you can do conditions, T to I, some T to I paper, ControlNet or something. I don't know. And that could be a video, right? We could have a contrastive video where what I really want to talk about is clip because I think that's the big one. But then we also talk about this like arms race where these papers come out at the same time. And then we could also talk about how, like, we could briefly mention the dyno alternative. I really like knowledge distillation as its own thing. And then we could highlight papers that show major applications of it. Maybe. Or maybe we really just do knowledge distillation. We've also talked about AlexNet being a paper. We could reframe like we could do a CNN video where the focus is AlexNet, but this is where we have a chance to get the history, right? And we can talk about some of the funny controversies, right? Like we could talk about DanNet. And we could also mention that the architecture gets some updates, and we could spend time on ResNet and ConvNext. We could talk about transformers. Right? And this would get us like right, because I'm talking about I'm talking about 30K citation papers. How many cites did Swin end up getting? Over 40K. I mean, like, I'm talking about an entire video for an area that has less cites than this paper. I almost feel like I overlook Swin sometimes, but like, can we really skip Swin? Like, what am I missing with Vision here? And I feel like the answer is obvious. I'm missing 3D. I have an excuse for missing 3D. My hand-wavy excuse for missing 3D is now the domain of this, which replaced a deep learning method, but this isn't deep learning. Those are primitives. We use SGD, sure. We use gradient descent to learn them, but those aren't neural networks. So we moved 3D partially out of the purview of deep learning. And this is a CV deep learning. Okay, so something big that I'm missing here is I'm missing my data day. Totally. I've got the two architectures. I've got my image gen. I've got my understanding. Okay, I love knowledge distillation, but it's just kind of floating here as like one of my favorite things ever. But like probably if we were saying that it's 5, knowledge distillation is not one of those 5. Right? Probably this one is data, which is tiny images, which is ImageNet, which is CIFAR, which is Pascal, Coco Kitty, maybe, which is Sun. I mean, I'd have to be very careful with what I decide are like important data things. The issue with having data be its own thing is data is kind of the point that I'm trying to make with AlexNet. And so to what extent does data need to be its own day, or is data a context for AlexNet? I'll say what else is missing here. Detection and the death of detection and long-lived segmentation is kind of missing here. SAM is missing, and anything pointing to SAM is kind of missing, which is a problem. I don't think those should be missing. Does SAM get its... SAM is so big and cool, I feel like it has to get its own. So like there's one that's like properly SAM. And the moment I cover SAM, I can cover sort of like the life and death of object detection, right? Including, how it survives in terms of the anchor-based methods being so fast that sometimes that's just what you want to do. So like SSD there as well. That gives me something important, right? And then obviously if I'm doing 3D, suddenly I can be like, the thing is, like, Gaussian splatting kind of just killed Nerf. It's like, if I was doing this 3 years ago, obviously Nerf. But, and like, if I did Nerf, I could do Siren. I could do other things. Like, I could do Nerf, I could do Nerf, I could do Siren. But to what extent are those needed now? I don't think they'll show up in my modern. I think that's Gaussian splatting, and it's like, I would do such a horrible job on Gaussian splatting too because I'm not a 3D person. I would have to like study for that video. Pose estimation? What paper? Tell me the pose estimation paper. You know what? I'll do that. See, and also when I'm trying to do just 5 papers, my CNN paper gets huge. And it ends up having so many different ideas. And it's like, I'd like to do this, like, what is a feature paper? Like, what are features, right? And that's where I can do, like, hog. That's where I can do, like, sift, hog. That's where I can do DPM. Maybe some other things. DPM leads into CNN very well. But it doesn't make sense why I'm talking about DPM until you know CNN. So arguably, this is a paper that I do, like, after I've already said what AlexNet is. So it's like a different video. Yeah, I forgot text and VLMs, right? Like, I've explained all of the building blocks, but like, yeah, like this is where, we're mainly concerned with lava. Is it? No, I think that's where we got lava. That's where we got blip 2. That's where we've got, I mean, anything modern, right? There's tons of technical reports that we could pull up related to this guy. We don't have video. I can think of lots of papers for video off the dome. Like I can think of i3D, I can think of Frozen, I can think of many things. What matters though? I can think of Sora when we're talking about video generation. From VLM to VLA. That VLM to VLA feels like an aspirational paper though. Like the last thing I want this to be is a speculative series, right? This should kind of cover what looked like in March or April 2026 to be the settled parts of computer vision. Not me saying I think this is going to start being a big thing. And I feel like we're still at VLM. We're not really at like true VLA, but I don't know. Yeah, see Hassan, what about video understanding? I can say some of those papers, right? Like some of those early papers that would take like bird and clip and just try to kind of hook them up to each other and just process a lot of videos through the image. The problem is like contemporary to all those like 2021, 2022 video question answering papers, you have stuff like you have papers like this that would point out that none of those models do better than the table, I think will explain it. None of those papers really beat the single frame if you pick it right. And that's basically what this paper does, is they're like, just pick the frame well. And you might as well be just using the image model and not bothering with the video. Like, so these early papers didn't do video that well. And even now, it still feels like the video of it all is an afterthought. Like, we'll use the Qwen3 VL for image or video. And it's like, yeah, it does fine for the video, although there are some problems in those models with how like the rope handles like the drift between certain things. And obviously, like I said, it's kind of like the LLM's always allergic to the text tokens. But like what's the good video paper? Like Hassan, if you feel like you know what the good video understanding paper is, feel free to tell me what you think it is. But I really struggle to pinpoint like that one paper. But anyway, I feel like maybe the other thing is 3D, and 3D is mainly about how Gaussian splatting for now kind of subsumes NeRF. And those are the things we cover. So I guess, is this pretty thorough? If this is 10 papers, does it kind of get us everything? Is knowledge distillation worth its own paper? I feel like it's used everywhere. Or am I just being sentimental? I mean, let's look at the sites on knowledge distillation, right? I feel like it's got to be bonkers. What's the knowledge distillation paper called? That's actually just SimClear level citation. So it wouldn't be psychotic to skip it, but I'm also not sure what I want to fill it with. If I were to like skip, and if I were to say 10. Because I could say these 10 papers, by the way, and then, okay, here's the problem though. With Sam, like, is that a technical report? Like, how decent is this paper? I don't really remember. Oh, this is very decent. This will be good. This will be good. Okay, okay. So yeah, this can totally be SAM. Like SAM is the proper paper. Okay. Attention is all you need is no. VIT is the proper paper. We probably spend a lot of time on attention is all you need. Or is attention is all you need the proper paper? And we spend a little bit of time on VIT. I'm not really sure about transformer architecture. I recently benchmarked video LMs on fault attribution from dashcam footage of car accidents. Gemini 3 Pro is barely better than random. Kind of lost hope in video LMs after that. Tell me the newest video LM that you benchmarked. I know you said recent. Like, are you saying Qwen 3 can't do this? I'm kind of curious. Sam's. Like, does Qwen 3 struggle with this? Or like what's the newest model that you were testing? And the biggest. Newest and biggest is my main curiosity. Qwen 3? Oh wow. That's interesting. Barely better than random. How well does like I guess you got some annotation, so the humans have decided. I wonder how much ambiguity there is in a task like fault attribution in an accident. I would say 3D should also cover multi-view diffusion progress, like Cat 3D. Maybe. Um, let's see. Citations are not the way to measure this, by the way. I'm just kind of curious because sometimes they can reveal my blind spots, but sometimes it's like there's a ton of computer vision that we're just not getting to here, and it is sort of meant to be like the highlights. Although you're absolutely right, there is a ton of work lately. We've even gone over papers on the stream where it's like, how can I pipe 3D representation into the diffusion model and get 3D representation out of the diffusion model? Maybe that means it is some kind of good mention, right? Like, but to what extent is this a thing that gets shoved into diffusion? And to what extent is this maybe replacing knowledge distillation and it's sort of like bridges between 3D and diffusion, 3D and VLM, audio and diffusion, audio and VLM, right? There are problems on all sides of that. Like, how do I get the audio signal into my VLM properly, audio signal out of my VLM properly? This is where things start to get kind of harder to pin down too. I feel pretty good about this overall, though. I'll definitely think about it a little longer. What about RL and CV? That's a great question. Like, I'll put it back to you though. What does RL really do well in CV? It's definitely a way that you can improve your diffusion model a little bit, kind of like how we do with LLMs. Is it really that mainstream though, or is that mainly a thing you see in academic work because of compute constraints? Um, I don't know if I see RL as a first-class citizen in Vision or just as something that we borrow from language in spots where it works. But yeah, I don't know. Maybe I do need to be covering GRPO. I'll put that as like a question mark. And here, we'll take the Cat 3D out of here. Like these are like things that aren't really covered, but are kind of important. What else really matters that we're potentially missing? Also, last call for questions. I think I'm hopping off in any time in the next 5 minutes as I run out of questions. See you later, Zung. Good to have you. Yeah, I think this is last call for questions. I think I accomplished most of my goals for the computer vision brainstorming stream. I think everything that we're missing at this point is really just a matter of the taste of every specific person, and you can't win them all. And some of it is also just an artifact of like the way that I view the field, which is different from the way that other people view the field, right? Like maybe there's people still working on object detection that aren't listening to Ross and don't think that it's bad or dead. You know, that's possible. Anyway, I'm not seeing any other last minute questions coming in, and I did do pretty much everything that I had vaguely planned for the stream. I covered the last papers from yesterday. I planned a bit the computer vision series. I should rest my brain now. I think that we got to a good stopping point, and just for anyone that's still here, I will be live every Sunday at 9 a.m. That is the plan. I wanted to test it today before I made an announcement on the channel. Also, I know people like Hassan have been asking about Discord. I think we will be doing something along those lines. I just need to make sure I feel totally comfortable with it before I launch it. But that'll be a good place. Like today, I was 15 or 20 minutes late. I won't ever say that on the channel. It's just sending too much out to too many people that don't necessarily care. I would be posting that quick in the Discord though. I'd be like, hey, sorry everybody, 20 minutes late, you know. And I would also be able to post like going live notifications and stuff like that. So the Discord is something I want. It's something I'm thinking about. This series is something I want, something I'm thinking about. And then next time you want to catch me live, for sure, Sunday at 9. Although, if at any time I'm home and my wife happens to be out with the kids, those are times I'm likely to just hop on and do a random stream. Just FYI. So you'll keep seeing random streams, but if you want to know for sure when you'll catch me live, Sunday, 9, reading papers, answering questions. See you then. Bye.